Hello everyone, I am Varun Joshi and I welcome you to Cloud with Varjosh, where we build real world DevOps and cloud native systems through hands on production focused demos. Today, we are building a full production grade DevSecOps pipeline, the kind that will help you in interviews and in real world project work. We will combine Jenkins, SonarQube, Trivy, Amazon ECR, Amazon EKS, RBAC, image scanning, and build AZ rollouts. We will cover installation and configuration of Jenkins controller on EC2. We'll be setting up a secure SSH based Jenkins agent, install SonarQube with PostgreSQL and configure quality gates, build the CI flow, Git, Trivy file system, Maven, Sonar, image scan, ECR push, and so on. We will be provisioning a multi AZ Amazon EKS cluster, configure IAM, configure AWS auth, config map, RBAC, and deploy with rollout checks. Run the entire flow from code push to a secured production grade deployment. All commands, manifests, IAM policies, and the Jenkins file are available in the GitHub notes so you can follow along easily. So let's get started. Like in life, this lecture also has some prerequisites. So let's quickly visit them and after that, we'll get started. I'll go to my browser and here I am in my YouTube channel. So, firstly, you should have good understanding of Maven and SonarQube as we will be using these tools extensively in our demo. There are certain Jenkins concepts and other Kubernetes concepts that you must know as we progress with this lecture, but all of those things are already covered in my channel. I will link appropriate videos where required so that you can learn without interruption. With that being said, let's go to the diagrams and see what are we going to deploy in this session. So demo, end-to-end production DevSecOps pipeline. See, here the orchestrator that will be orchestrating our entire CICD will be Jenkins. We will have a Jenkins controller and the tasks that are related to our projects will be performed by a Jenkins agent so that there is proper role separation and the controller just handles the logic, the control plane, and there is an agent that is actually running the job for you. Now let's see what all stages or what all steps will be there in our pipeline and have a sky by view of all the things. First is check out private Git repository. So like in production implementations, I'm sure your application is also hosted onto a private repository. Now that a repository could be on GitHub, GitLab, or any other offering. But in this lecture, we will be leveraging GitHub as our private repository. Now, if you have a private repository, then if you want to access that repository, you will need credentials to do that. And that is exactly what we are going to do in the very first stage. Now, to give you a background of the application that we are deploying a Java application, a very simple Java application that just says welcome to cloud with Varjosh. Hence, in the repository, what we will start with is pom.xml along with the source code. And as we progress, there will be more things that will be added to that repository, more things like the Docker file, the Jenkins file, and so on. But we will start with the source code and pom.xml, and that is exactly what your developers will be doing. Your developers will be pushing the code along with pom.xml into a private repository, and from there you DevOps folks will start your work. Now I will be mentioning DevOps because as you know, the line between DevOps and DevSecOps is now blurred. So everything, including security, is slowly and steadily moving in the DevOps side of things. In the second step, we will be performing a Trivy scan, and this Trivy scan is SCA. And if you remember, we learned in our SonarQube lecture what exactly is SCA. What will SCA do? SCA will scan for vulnerabilities in your third party libraries. For example, we know that in Java we define all the dependencies or the third party libraries in our pom.xml. So Trivy will be scanning this pom.xml to see whether there are any vulnerabilities in the dependencies that we have defined or not. And Trivy is not just SCA, it will also check our OS packages. It will also check whether there are any secrets that are openly available, the well-known patterns. For example, maybe you have AWS secrets in your source code, and you should never be doing that. Trivy will be able to detect that. So the first step is scanning SCA, and if this fails, our pipeline will fail. And that is what we want in production. We want that if something is not right with my code, if my code or my dependencies, they have any vulnerabilities, I want my pipeline to fail. Then next we have build plus test. In the build stage, we'll be leveraging Maven to build our code, and then we will be performing scans using a plugin called Sonar. And as you see in the next stage, we have SonarQube analysis, which will be performing SAST, that is static application security testing. And in case if any of these things fail as in if your code has vulnerabilities and your quality gates define that I cannot pass this code if there are any vulnerabilities, or if your code coverage is less than, let's say, 80%, then I will not allow the pipeline to move forward. I will fail this pipeline again. If you have not watched the Maven and SonarQube lecture, these things will be a foreign language for you. So I request you to first go through that so that all things in this demo make sense to you. And in the next stage, as we know, we'll be doing ECR login, plus we'll be building the image. So if you want to build the image, then you must have tools that are required to build the image, such as if you are using Docker, you should have Docker installed to build your container images. Then ECR login. So if you want to, at some stage, push your container image to an image registry, then of course you will have to log in into that image registry. And in our demo, we are using Amazon ECR to host our container images. Hence, in this stage, what we'll be doing is we'll first be performing ECR login, then we'll be building the image, and in subsequent stage, next stage, we'll be pushing that container image to AWS ECR. At this stage, I want you to understand that we will also be performing Trivy image vulnerability scanning. Varun, we have already performed SCA here. We have already performed SAST here. SAST is, which is checking your code for vulnerabilities. SCA was checking your dependencies for vulnerabilities. SAST is checking your code for vulnerabilities. Understanding the difference is the key here. And then here, the Trivy image scan is performing the scan on your image. But Varun, we have already done these things. Why do I need to scan my image? I want you to clearly know that your Docker file uses a base image. In this step, we are scanning your base image for any vulnerabilities. And again, in this step as well, if there are high or critical vulnerabilities, if there are any findings like this, then we are failing the pipeline. I want you to clearly know that there are 3 stages where we essentially are failing the pipeline. If our desired thresholds are not met, this is the key point here. For example, maybe for application 1, 70% code coverage is all right, but for application 2, at least 90% code coverage is important. So for you DevOps folks, it becomes imperative that you configure these quality gates, these failures, these successfuls based on your app requirement. And then, as we discussed here, we'll be pushing to AWS ECR, and then finally we will be deploying it to Amazon EKS. And I believe this is the step where everything will come together: your AWS knowledge, your authentication knowledge, your authorization knowledge, because we will be leveraging principle of least privilege. So our Jenkins, which will be deploying resources onto Amazon EKS, must authenticate and must only be able to do things that we allow it to do, nothing more, nothing less. So with that critical understanding, let's get started. So in this demo, the first step would be to configure our infrastructure. So we'll be configuring 3 things, and straight away we'll be doing that. First, we'll be creating a Jenkins controller. Second, we'll be creating a Jenkins agent. Third, we'll be establishing the communication between the Jenkins controller and Jenkins agent, and that is where SSH comes into picture. And then at the very last, we'll be configuring SonarQube with an external database, which is something that you would see in production implementations. So with that said, what I will do is I'll go to my GitHub repository. I'll go to my browser first. Here I have this repository, Jenkins Basics to Production. I have added project 1 here. All the steps, inch by inch, word by word, are mentioned in my repository. So you can follow along with me. And if it helps, do start the repository. It helps me a lot. Now, first step is install Jenkins controller. So let's go there, and you see I am using C7i flex.large instance. I'll be using this instance for all the 3 components: my controller, my agent, and SonarQube. This provides 2 vCPUs and 4 GB of RAM, which I feel is sufficient for these demos. Now, if you want to lower the instance type, then you can maybe use t3.small, but I have used C7i flex.large throughout this lecture, and this falls under the AWS free credit. So if you have those credits, if you don't have those credits, then I would encourage you to create a new AWS account with all the details, and then AWS will give you, I think, 120 free credits to begin with, and they will also give you 50 more if you clarify certain criteria for them. Anyway, I'll let you figure that out. For now, let's go to the console and let's start creating instances. I'll click on launch instance here. This one, I want everyone that is following this lecture to be very specific with nomenclature, because nomenclature will help you a lot when you are dealing with a production grade issue. So Jenkins controller is the name that I'll give to this machine. This is the name tag, not the host name of the machine. The host name will be changing once the machine is configured for us. I'll be choosing Ubuntu. Instance type here, I will change this to C7i Flex Large, which is free tier eligible. It will give me 2 vCPUs and 4 GB of memory GB bytes. So I'll click here. Key pair, I have already created a key pair, and key pair is called cloud with Varjosh -sj -Mumbai. I want you to know that these key pairs are regional in nature. So if you are dealing with an AWS account and you deploy resources to multiple regions, then I encourage you to always have the region name in your key pair naming. Another point I want to highlight, I am calling this account cloud with Varjosh -sj, which is why I have it here, so that if I have multiple key pairs in my machine, I know that which key pair to be used for which account. This gives you a clarity. Hence, I highly encourage you to use naming that helps you understand when you look at this 6 months down the line, because I assure you, you won't remember. Now, if you do not have a key pair, just click on create key pair. Here, the algorithm that you should be choosing is ED25519. You could choose RS as well, but this one is a latest and greatest one which you should be using. Anyway, so I already have this key pair created and I have selected that. I'll scroll down. I will be using the default settings here, but here I will be choosing an existing security group, and the security group, I already have 3 security groups created. I will be choosing the security group that I have created for Jenkins controller. Just to give you a quick glimpse of it, I'll open this in new tab. I will go to security groups and here I will select the Jenkins controller. Now, the inbound rules I have is port 22 is allowed from anywhere, and this is something that I am using, and you can be restrictive with it. You can only allow your source IP, but I have configured these for simplicity. In actual production implementations, you would see that only what is needed is allowed. And if you see the latest trend, this trend of setting up jump hosts or SSHing into machine is slowly moving away when you are on AWS specifically, because you would be using systems manager, which provides you other means to log in into your machine rather than using SSH. So you would be typically using those things here, not the traditional jump hosts or Bastion hosts that you would have used before. Second, I am allowing port 8080. Now 8080 is the port on which Jenkins listens. So I am allowing that. And again, I'm allowing that for the entire world, which you might not be doing in production, but I'm doing this for simplicity. Then we have done this. I also want to give you a walkthrough of all other security groups because we are already in this screen. And then we have Jenkins agent, and Jenkins agent, I am only allowing port 22 here, only SSH. It is the Jenkins agent that is listening on port 22 from everyone. Since we will be connecting to our Jenkins agent from Jenkins controller over port 22, that port 22 is already allowed in our Jenkins agent so that Jenkins controller can connect to it. Now, previously JNLP was used, Java network, Java network, hold on, I've forgotten the name. JNLP, Java network launch protocol. Yes, Java network launch protocol was used, but now we are using normal SSH connections, and that was used because, you know, if your agent was sitting behind the firewall and so on, but now it is preferred to use SSH based agent, and we'll see this briefly as we progress. Then we have the SonarQube SG. SonarQube SG, again 22 is used so that I can SSH into SonarQube, and then I have allowed 9000 so that I can access the UI of SonarQube. So this is for SSH and this is for UI. Again, when Jenkins interacts with SonarQube, it interacts on port 9000 itself, which is why you do not have to allow anything else. Again, in production implementations, you only allow what is needed. Do not allow anything else. Principle of least privilege everywhere you go. Now launch instance, here I will come, I'll change this to 20 GB. Now when we will be configuring agents, we'll have that 30 GB and I'll explain that to you later, but for now let's keep this 20 GB, and then I will click on launch instance. I'll go to instances and I see this is pending, and while this is pending, let's also create an instance for SonarQube. We'll just creating that instance, we'll be configuring it after we have set up the controller and the agent. So let's do that later because I see this one has already started. So I'll click on connect, I'll copy this, and then I will go to my terminal, and in my terminal I will cd into .ssh directory. I'll press ls, and with ls you see I have so many keys here, private keys here, but I want you to know that this is the one that we will be leveraging. And I know this because I have done the naming properly, and of course at the AWS screen I chose this. And before I paste this, if I do ls-la, then you would also see that I have given appropriate permissions. I just have 600 for this key pair, so you would also prefer 600 for your private keys. I'll paste that here, and oh, I have to copy that again. Let me go there. I'll copy this and then I will paste it here. And this is asking me, do you trust this? Now this is called trust on first use. We'll briefly discuss this later as well when controller is making connection to the agent. So I'll press yes here, and this is added to my known hosts file. Now if I connect to this machine any other time, it will not ask me to type yes or no, because the fingerprint is added in known hosts. I trust the destination I am accessing because it is indeed the destination I want to access. So I will go to my GitHub notes now, and here let's start configuring. So the permissions part I've also mentioned here. The first thing is we'll be setting the host name, because we don't want these generic host names. We want particular host names that tells us what that thing is doing. So I will copy this, I'll paste it here. Exec bash will just refresh so that we see the changes right away. And then I want to change the time zone. Understand that this command is changing the time zone of the Linux operating system of this machine. But when we install Java, the JVM part, we still have to change the time zone for the JVM part, so that when you work with the UI, you see the correct timestamps in your logs too, in your UI too. So I will again go back here. Now we'll be installing Java 21. This is JDK. Now understand that there are two options that you have. One is JRE and another is JDK. JRE is preferred when you want to just run Java applications. JDK is preferred when you want to also build the Java application. So JDK is used predominantly by us DevOps and developers, so that we can also do compilation and all other things that JDK comes with. But why are we installing JDK in the controller? Varun, we are not building anything in the controller. We will be building things in our agent. So agent must have JDK. That part we understand. But why do I need to install JDK in my controller as well? The reason for that is Jenkins core and plugins depend on JDK tools. JDK ensures that you have maximum compatibility, stability, and plugin supports, because we will be leveraging different plugins, and there could be a plugin which also requires JDK. Hence, in the controller as well, I will recommend you to install JDK. So I'll copy this, and then I will go to my terminal and I will paste it there. And this will install JDK. Then is the part where we add Jenkins repository. So these steps will add the Jenkins repository, and then once the repository is added, we can install Jenkins. But before we do that, we are also running sudo apt update so that our indexes have the information about the latest version. So I will copy this thing, and then I will come here, let it finish, and once it finishes, I'll paste that onto here. I will paste this here, I'll press enter. And all these steps that you see here are taken from the official documentation, and you can see the reference link here too. Now is the part that I was telling you. Now we'll be setting the JVM, the time zone in the JVM as well. So that is what we'll be doing. Now you could use this. It will directly do the changes and will let you know. So let's take this one, or you can manually just add this part in your, Jenkins service. I will copy this. This is essentially modifying the, unit file that is created for Jenkins. So I'll go here, I will paste it here, and then it has done its job. And before I Yeah, let's do these things. So first we are doing a daemon reload. Why a daemon reload? Because we have done some changes in the unit file, so it is always good to do a daemon reload. Then we are restarting Jenkins, and finally we are checking the status of Jenkins. Now I don't know why these steps are repeated. Let's just copy this, and then I will also run one more command, which is like enable Jenkins, so that even if we reboot our system, Jenkins service automatically starts. So it is active and running. I will hit Q here and I will paste that command and it will enable Jenkins. And then I want to check the status of Jenkins again. It says that Jenkins is up and running. So let's go to our browser. I will go here. I'll go to instances. This instance is already selected. I will copy this thing and I will paste it here. And then I will also add 8080, and I will explicitly mention that this is HTTP, not HTTPS. I'll press enter and voila, we have the Jenkins screen in front of us. It is asking that you can check the initial password here. So we have already SSH'd into our Jenkins server. So we'll go here. I will write sudo cat. I will paste that path here, and here is my password. So I'll copy this thing and then I will paste it here. I will hit continue. I'll press never here, and then I will be installing the suggested plugins. Now, why I'm choosing this? Because it will by default install everything that we need initially. Now, I want you to know that in my Jenkins series, I have explicitly covered what all these things are and why we need them. But for now, just a quick overview. We won't be using Gradle and or LDAP. These things we are not using. We would be of course using the dark theme, and then Git of course we would be using. So understand at this stage itself that the Git plugin is already installed and is again a build tool for Java. Gradle, again, an advanced build tool for Java, especially if you are using Android applications. Pipeline graph view we need, and I'll show this to you while we will see how our pipeline is behaving. And then there are a few more. So we'll let this finish. Until that time, let's see what we want to do next. Yeah, this can finish in the background. Till this point, we have already done what we wanted to do. Now let's start configuring our Jenkins agent. Now again, in Jenkins agent, I will be assigning 30 GB of storage, because when I assigned 15 GB of storage, I was constantly getting disk issues. This is because all your tools that you will be installing in agent require some storage, and as we progress you will see why. But at this stage itself, I want you to know that Jenkins is just an orchestrator for you. So for example, if you have to run any commands that are specific to Maven, if you have to run any commands that are specific to SonarQube or to Trivy or to AWS or to Docker, then you must have those tools installed, because Jenkins is just an orchestrator. It will help you move from point A to point B, but to reach there you must provide Jenkins with all the tooling that it needs. Now since it is our Jenkins agent which will be running all these jobs for us, we must ensure that we provide that agent with all the tools that are required. Hence all these tools may download Trivy, may download CVEs to their local database first. And then if I talk about Maven, if you have watched the Maven lecture, there is a local repository created, and that will also take some storage, which is why I would suggest you to assign 25 to 30 GB to your agent, because agent will be doing the actual legwork. Hence agent must be provided with sufficient resources. For compute and memory, C7i Flex Large should suffice. So I'll come here, I will select this Jenkins controller, action, image and templates, launch more like this. And this time I will call this Jenkins agent. Rest, I am satisfied with most of the things. I'll change the security group first. I will choose select existing. I will remove this controller one. I will choose the agent security group, Jenkins agent SG, and then here I will choose 30 GB, and then I will press launch instance. Now I want you to know one more thing very clearly. There is a difference between security group name and the name. This name is the name tag. This is the name of the security group itself. Now if I go to the tags, let's select this agent SG, and if I go to tags, I don't see any tags here because I have not defined the name tag. That is why I don't see anything, or I do not have any other tags as well. But this is the security group name itself. This is not a tag. So this is a nuanced difference. Most of the folks do not understand. There is a difference between a tag and the actual security group name, and this, this changes if I move to my instances. So if I go here, the name that you provide while creating the instance is actually the name tag. So if I move to tags, you see the name tag is added and the value for that tag is Jenkins controller. So understand this nuanced difference. I'll go to my agent VM now, and here I will click on connect. Then I will copy this, and then I will go to my terminal, and what we have is, it has named this one Jenkins controller, which is what we wanted. I will press Control T so that I get a new tab. I will zoom in a little here. I will cd into .ssh because that is where my private key is. I will paste that command. This will work because this key is in my working directory, in my current directory. Now if you have this somewhere else, then you may have to provide that path. Not may, you will have to provide that path. I'll press enter again. TOFU, trust on first use. I will say yes, and then I will clear my screen. Again, we'll follow the steps from our documentation. That documentation is golden, not just for this demo, but as you are working in production grade projects, you can always come and refer this for creating or dismantling any infrastructure. So here, let's move to our controller step. This is SSH based Jenkins agent on EC2. We are here. Let's run this command. Here we are setting up the hostname. Hostname is Jenkins agent, which is explanatory. Then we'll set the time zone, and then we'll scroll down. Again, we'll install Java 21, and here as well we need JDK, and we know why we need JDK, because it is the agent who will be building the apps. If you have Maven, Maven will require Java underneath, and Maven to perform the compilation for you, to perform the packaging for you, to perform the verification for you, it will require Java 21, not 21. It will require Java Development Kit, that is JDK. Now I want you to clearly know that you will not use random users to perform tasks. You would want that all your Jenkins tasks are performed by a user that you explicitly create for Jenkins. So I will not be running my Jenkins tasks using this Ubuntu user. I will create a separate user Jenkins so that that user is the one that is running commands for me. So I will copy this. I will paste this here, and you have detailed comments in my GitHub repository so that you know what we are doing. Here -m says I want the home directory for this user. -s says the shell for this user will be bash, that is the born again shell. Now our Jenkins agent till this stage is kind of ready, because Jenkins agent just needs Java installed, that's it. But we have not told the controller that this is the Jenkins agent. Now to do that thing, we first have to have some sort of connection between the controller and the agent. So first I want you to understand that connection. So I'll take you to my diagrams, and then I will take you here. Now again, I have discussed the mutual authentication that happens in SSH in a greater detail if I talk about my Kubernetes TLS section. So if you want deeper understanding, then you can always watch that. But here I will explain that to you very briefly. So here is our Jenkins controller that is running on an EC2 instance, and here is the Jenkins agent, which is also running onto an EC2 instance. So we have configured both of these. Now we want to SSH from our Jenkins controller to our Jenkins agent. To do that, first we will be generating a key pair using SSH keygen utility, and we'll be generating this key pair in the Jenkins controller itself. Now once the key pair is generated, what we will do is, we know that mykey.pub, which is the public key of the key pair that we generated. So this is the key pair we generated, and we generated this key pair in the .ssh directory itself. Now you would be thinking, why is this var lib Jenkins? I want you to know that if I talk about Jenkins, the default Jenkins home is var lib Jenkins, but the user that we manually created in our agent, the home for that user will be /home/Jenkins itself. That is what we expect. If I create a user varjosh, then the default home would be /home/varjosh. Similarly, if I talk about Jenkins, what it has defined in its configuration is, the home for me will be var lib Jenkins. As simple as that. Now since its home is this, our .ssh directory will exist here, and then here is where we'll generate our key pair. Now if this directory does not exist anywhere, we will create that, but for understanding, we are saying that we will be creating these key pairs in this directory, and once this key pair is created, we know that this public keys information, this public keys data must be available with the Jenkins agent in the authorized _keys file. So what we will do is, we will be creating this key pair, then we will be copying this key onto our Jenkins agent. As simple as that. Once we have done that, Jenkins controller can SSH into Jenkins agent by using this private key, and Jenkins agent, the SSHD daemon that is running in the Jenkins agent, can identify that indeed the private key presented by the Jenkins controller is associated with the public key that is already there in my authorized keys file. As simple as that. So we'll be doing this. Now few bullet pointers. Jenkins controller acts as SSH client. We know that because this is the one that will be initiating the communication. Second, initiates communication, and the one who initiates communication is called the client, and towards the entity for which the connection is initiated is called the server. So this is the client, this is the server. And then lastly, runs build via SSH agent. So whenever we are scheduling a job and running that job, Jenkins controller will be asking this Jenkins agent to run that job. So Jenkins agent acts as SSH server, receives public key, executes pipeline steps. We know that. I hope this understanding is clear. Now let's go to the GitHub repository, and while I do these things, you will understand them in a better way. Now generate SSH key on the controller. Now I want you to clearly focus on one thing. What I'm doing is, I will be generating these keys and I will be accessing this as the user Jenkins. Now what is the significance of this? Now the Jenkins user created in our controller will be the one who will be generating these keys. I don't want to use that Ubuntu user. I want to do things like we do in production implementation. So I'll copy this one. I will go to my terminal. I will go to my controller, and here I will clear my screen for better visibility. I'll paste it here, and you see the key part. We have, logged in into this one because we have typed sudo su -Jenkins. We have logged in as Jenkins user. If I press ls, you see these are all the details about my Jenkins home. So these are all the things that are available in Jenkins home. Now if you have watched my previous lectures on Jenkins, you will understand what all these things are. But for now, I will just write ls-la. You see .ssh is not yet created here. So let's do that thing. So I will do mkdir.ssh, and then I will cd into .ssh. I will do ls. I don't see anything here. Now what I will do is, now I will be running this command, because this will make sense once you have .ssh directory. So I will copy this. I wouldn't have to enter in here, because I am using absolute paths here, not relative paths. So I will press enter, and this has started the process of creating this key. Now I want you to understand this command as well. This is just a comment that we are adding, and we are saying the algorithm that I want you to use is ed25519 -f is, this is where I want my key to be located. So I will press enter. I will not assign a passphrase. I will press enter again, and if I do ls-la, you see that I have a public key here, and this public key needs to be transferred to our Jenkins agent. Now again, I will just be catting this file and copying the content and pasting it there. But you can also use SSH copy ID and so on. There are plethora of options to copy a file from one Jenkins server or from one Linux host to another Linux host. Since this is not a Linux course, I won't go into telling you SCP commands and SSH copy ID. For simplicity, we'll just be copying the contents and doing our job. So we'll copy it in a little while, but first let's see what we want to do in our Jenkins agent. Copy the public key to agent VM. So here we are saying this, just copy the file, and on the agent SSS session already open, switch to Jenkins user. Understand that we just created a Jenkins user in our agent as well. So what we want to do is, we want to leverage this Jenkins user to perform anything Jenkins. Now I want you to know that when controller accesses our agent VM, it will be using this Jenkins user. So if I want to SSH into a destination, I must provide a username that exists in that destination. So the destination for my Jenkins controller is this Jenkins agent, and I am saying when you access your destination, you must use the user Jenkins, which is why we have created this user Jenkins, so that everything Jenkins is done via the Jenkins user. So I'll clear this for better real estate, and then I will just create a file here. So what I'm doing is, I'm first logging in using the Jenkins user. So sudo su-jenkins, and once I am here with the Jenkins user in the Jenkins agent VM, then I will run this one. I want to create a directory .ssh, and then I want to create a file that is called authorized key. So I'll press enter, and voila, I am in the file. Now I will come to my controller. I will cat the Jenkins agent key.pub here. I'll press enter, and this is my public key. I will copy this public key from here, and then I will paste this public key here. I will press escape shift ZZ to save this file. Now let's see what we want to do next. Here is, we are setting up the permissions. Like I told you, 600 is good for these files, these key files, so that only the user has the permissions, not others and groups. And then here I'm doing it same for the directory. .ssh is a directory, authorized underscore keys is a file. I'll copy this, and then I will just paste it here, and I'm on the agent VM. That is where I want to run this. I'll press enter, and this has done its job. Now let's go here. Now we have to test this connection from the controller. Test the connection. So what I'm doing is sudo su as Jenkins user. I want to SSH into my Jenkins instance, and I want to run the command hostname. So let's see whether this works or not. So when we run this command, we should see Jenkins agent. right? I'll copy this one. I will go to my terminal. I will go to my controller. I will paste this here, and here understand that our key is located in Jenkins home in the controller, and in the controller the Jenkins home is var lib Jenkins. So I'll go here, and here is the placeholder for agent's public IP. I'll go to my console, I'll go to my browser, and here I want the public IP of my agent, which is this. I will come here, I will paste that here, I will press enter, and I want you to pay clear attention here. This is showing the fingerprint and saying, do you trust this? As in, it is asking you to verify whether this fingerprint is for the server or not. Now, I am not going to do that verification for now. That is why I am just pressing yes. This says trust this on first use, and then continue to trust this until this identity changes. So if you, let's say, are not using an elastic IP, and if you just stop this Jenkins agent and then start it tomorrow or start it after a couple of seconds, then this public IP will change. And when this IP changes, you will again have to do this because the identity that you trusted here has changed. So understand these nuances of SSH. It is of paramount importance. I'll press enter. I'm trusting this, and it has shown me the host name. So SSH works and we are good. Now let's go to the notes and see what we want to do next. You have SSH'd from controller to your agent, and that works. But how does the controller know that where we SSH'd is actually an agent? We don't know that. The controller doesn't know that. So we will have to tell the controller that the agent where the jobs will run is this, and that is what we will do now. So we will go to the Jenkins UI. Finally, we will create a user cloud with varjosh, let's call it that, and password, let's give it a secure password. I will give the same password here. Name is Varun Joshi, and the email is cloudwithvarjosh@gmail.com. And if you have any feedback, if you want to share anything personal, then feel free to communicate with me on this email address, cloudwithvarjosh@gmail.com. I will click on save and continue. Now this is the Jenkins URL. Again, when you are dealing with production implementations, you would have a DNS name for your Jenkins URL, and that DNS name will obviously point to an IP address, and that IP address, even if it changes, although it wouldn't, but even if it changes for your specific use case or for your specific implementation, then the DNS name will always remain the same. Hence, it is recommended what you provide in Jenkins URL should be persistent, because if you are running certain post actions as in once your pipeline runs, you do this. You could be sharing these things, these URLs with your teammates or with your, let's say, team leads, who when click on this URL will directly be taken to the logs page or to the Jenkins URL, which is why it is important that you provide a functional URL that remains persistent. Now, because if this URL changes, you will have to update this URL in the UI. It is doable, but it is recommended you choose a persistent name here. So always access your things using DNS names, not IP addresses. I'll click on save and finish. Start using Jenkins. And firstly, before I go blind, I will be changing this appearance to dark mode so that we can work safely. Yes, I have changed it to dark mode. Now, if I go here, I just click on settings. I can click on set up the agent from here as well, or I can click on nodes and configure my agent from there. So I will click here, and here I will click on new node. What is the name of the new node? Let's call it Jenkins agent. You can give it any name. This is a permanent agent, which is fine because this is the one that it will be there forever in at least our scenario, forever as in till we do this pipeline. And I'll press create. Here description, you can add it, number of executor. What this means is how many jobs can this agent run in parallel. Now since I have vCPUs, two vCPUs, I can choose two here so that we can have parallelism here. But if you do not want jobs to run in parallel, you can have one. If your agent has, let's say, 20 CPUs, and you can even have 20. It doesn't have to be one-to-one with vCPUs, because this decision is subjective and will depend on what sort of deployment you have. So for now, I will just choose one executor here, because we for sure will only be running one pipeline at once, and number of executors one should suffice. And I also want to go to the Jenkins, our repository, so that I can see the steps here as well. So name Jenkins agent, type permanent agent. I've written everything here so that you can work in peace. Here Jenkins remote root directory. Now here you would specify the directory where your workspace will be created. So workspace as in when you are running a job, when your agent runs the job, it will create a workspace, and workspace is like a scratch directory. So for that, we have created the home directory of Jenkins user. We would want to create that. Now again, extremely important, permissions are of paramount importance. We have created a user Jenkins, right, in our agent VM, and we are providing the home directory of the Jenkins user itself. So whenever our controller accesses our Jenkins agent using the username Jenkins, which is already there in our Jenkins agent, it will by default have access to its home directory. So it is important that you take care of permissions. It's not that you can provide any path here. Provide the path for which the Jenkins user has full access. So I'll write this here. Then labels, see, you can call it anything, but I like to be descriptive. Hence, I will provide this name, Docker Maven Trivy. Now, this will have other tools as well, like kubectl or maybe EKS CTL or definitely AWS CLI. But for now, we are providing it this label. I'll come here, I will give that label here. Usage, use this node as much as possible. This is fine. Launch method is launch agent by connecting it to the controller. And here is the part where I'll change it to launch agents via SSH. And then it is asking me to provide the details. Again, it is asking me to provide the details of the agent. Here, I could provide the public IP address of my agent, but that is not how you would do things in production. In production, you would supply the private DNS name for your agent so that your controller doesn't have to walk miles to reach your controller on a public IP. And when you are using a public IP, the traffic from AWS first goes to the internet, then to your instance, and we don't want that. This is an internal traffic. We want this to stay internal. Hence, we will provide the private IP address of the Jenkins agent here. I want you to clearly know that you would be using private DNS names in production. So you could be using this name, but for this demo, I will be using this private IPv4 IP of my agent for my controller to make connection to it. So I'll come here and then I will provide this IP here. Now it is asking for credentials. Now credentials as in how do I connect to this host? And remember, we are connecting by supplying our private key. So we'll have to provide the contents of our private key to this UI so that when controller is connecting to the agent, it can do so seamlessly, right folks? So here I will click on add Jenkins. This is global credentials. This is fine. And here is the part where I will choose SSH username with private key. Just if you understand the concepts, these things will come automatically to you. We have created public and private keys. Hence, it is obvious that we will be choosing SSH username with private key here. Here it is asking us for the ID, and the ID that we can give here is Jenkins agent, which works fine for us. Username, we know what is the username. Username is Jenkins that we just created. Private key, on passphrase, we have not given any passphrase, that is fine, but enter private key directly. And here we can click on add, and here we have to add our private key. So let's go back to our terminal and copy our private key. So we are already in the Jenkins controller. We are already logged in as Jenkins, and then we are already in .ssh. So if I press ls, you see our private key is this one. So what I can do is I can write cat Jenkins key, press enter, and this is our private key. Now your private keys must be private. Do not do screen sharing or do not share them with anyone. These are meant to be private. So I'll copy this. I will come to my Jenkins UI. I will paste this here, and then I will click on add here. Now this is added, and here I can choose those credentials. This part is done. Host key verification strategy. Now I will be choosing the first one, known host file verification strategy. And what is this strategy? You remember I've been telling you, whenever I'm trying to access something for the very first time, it is asking me to press yes if I accept the fingerprint, if I trust that indeed the server that is I'm communicating to me has this fingerprint, and we have been adhering to trust on first use. Again, I would tell you that in our Kubernetes TLS sessions, I have demystified this in greater detail. If you want to look at it, go and check that out. But for now, what we have to do is, if I choose known host file verification strategy, which is what you would be choosing in production scenarios, and then keep this agent online as much as possible, I'll click on save. Okay, now let's see what happens. If I go to my Jenkins agent and I go to my logs, it is trying to launch the agent. First is, you can see these logs here. Let me zoom in a little. It is trying to launch our agent, which is all right. But if I go to my logs here, it says key exchange was not finished, connection is closed, trying in 15 seconds, there are 9 more retries. So it is trying to access that, but there is no one who can say yes, which is why it is again and again failing. Understand, we did press yes once, but that yes was only provided for this public IP, but the identity changes. If I am authenticating to my agent using the private IP address of my agent, hence I must first press yes with the private IP, and that is what we are going to do in this stage. Everything is connected, guys. Now I'll go here. I will again copy this private IP address of my agent. I will provide that IP here, and I want to show this to you in parallel. So if you go here, the Jenkins controller is still trying to connect to our agent. Okay, here, now I'll press enter. Now this is again saying the same thing. Do you trust? Because this fingerprint is based on the identity of the destination. The identity changed because our Jenkins controller is using a private IP, which is why it is asking us to provide these credentials. I will say yes. To say yes to the fingerprint, I'll say yes, press enter. It is added. If I go back here, it should now connect, because in the known host files in my controller, I have an entry for Jenkins agent, and it says launch failed. Let's wait for some more time and see how it works. So let's go here again and let's click on launch agent again, and let's see if this works this time or not. Let me also see if I've missed any steps. Okay, this is fine. This is also fine. Yeah. Yes, so we used this strategy. And I mean, we scanned it with this. You could also use SSH key scan to update the fingerprints. Let's see if it worked now. Log says launch failed. SSH connection closed. Let me go to configure. Home Jenkins. Use this node as much as possible. Launch node as credentials is Jenkins. And known host file is file verification strategy. This is fine. And yeah, this is correct. Log. Launch failed. We launch again. But if it works from the CLI, it should work from there as well. If I do ls-l, if it is working from here, then it should work from there as well. Yeah, ls-l is also working. ls-la is also working. So if I go again, let me see if I have configured the username correctly. Its username is here. Credentials. Where have I configured the username? And let me just re-verify these credentials, guys. I will go to credentials. I'll go to system here, global credentials, Jenkins agent, update. Username Jenkins is fine. And then key is also fine. Replace. Let's just see if it is working now. And this is strange. Let me try to home Jenkins. This is fine. Agent IP 3464. This is also fine. And here I was trying to update the credentials. Let me try to enter that again. I will come to my terminal. I will ls cat Jenkins agent key. Now I'm not sure why it is saying the format is not supported. SSH authentication successful, connected online. I really have no clue what happened. I just entered that private key again and it started working. And previously the error was also quite off. It was saying that algorithm was not supported, and we used the supported algorithm. Anyway, so now that our agent is successfully connected, let's see what are the next steps. So here, install Jenkins controller. We are done with this. We are done with this. Yes, we are done with this as well. Yeah, we are done with this too. Configure agent UI, done with this. Now we want to install SonarQube. So I'll go to instances again. I will click on the controller one, action, image and templates, launch more like this. And here I will supply SonarQube. And then I will come down. This is fine. Ubuntu is fine. This is fine. Existing security group, yes, but this time I will choose the SonarQube security group. 20 GB is fine for this. And then I will click on launch instance. I'll go to instances and then I will choose SonarQube, and then I will wait for connect to appear. And till that time, let's go to our documentation. Same thing, C7i flex large 20 GI, then the security groups we have already seen, and we will be starting from these steps. So I'll go to my instances, click on connect, copy this. I'll come to my terminal, and here I will press Control T. So the first tab is for controller, the second is for agent, and the third one is for SonarQube. So in the flow, in the sequence, like we configured. I'll cd into SSH. I will zoom in a little here. I will paste that command here, press enter. I will say yes for the fingerprint, and now you know why this exists. I'll press yes, and I'll clear my screen for some real estate, and then I will go to my browser. I will go to instances. I'll go to my documentation. I will start with setting up the host name. I'll paste it here. Then I will change the time zone. I will confirm the changes are implemented. Asia, Kolkata, I'm in India. And then I will copy this. And this is the key part here. And you press enter first. We are installing JRE here, not JDK. Why is that? This is because SonarQube requires Java runtime to work properly, and we are not building any application here, which is why we are good with just JRE. I am using version 21 throughout of Java, be it JDK or JRE, and then I will scroll down, and here is a typo. You would see Java 17 because Java 17 was the one I used before. Anyway, so let's scroll down. Install Postgre and create DB for Sonar. Now, this is a one-time activity. What we are saying is the SonarQube instance that we are running, we want the database to be hosted onto PostgreSQL. Now, ideally, what you would see in production is there is one virtual machine that is for SonarQube, and then there is another virtual machine that is a DB machine, and DB VM will hold your databases. Now we are not going to this level of bifurcation. What we are doing is we have a virtual machine created, but within that SonarQube virtual machine, we are creating a database for SonarQube. So in production, you would be using a different database, and then you would tell SonarQube how to reach that database. In this specific scenario, which we are using, I will just say localhost. But if you are hosting your database separately, then you provide the identification information of the database instance that is hosting the SonarQube database. And here we are installing PostgreSQL with common extensions. We will enable PostgreSQL, and then we will start PostgreSQL. So I'll copy all these commands. I will go to my terminal. I will paste those commands in the SonarQube VM, press enter, and this will start installing and running PostgreSQL. Now I will go to pSQL. pSQL is the CLI for PostgreSQL itself. So I will copy this, and then I will paste it here. Now you will see a Postgres CLI. Now I will be creating my database along with a password. I will be creating a user Sonar with password Sonar. And why I'm doing this? So that when my application tries to access this database, it can provide the authentication information which I am creating right now. So I'm creating Sonar user, and that Sonar user will have Sonar password. These are DB users. So I'll copy this. Remember to copy the semicolon as well. So I'll paste it here. It will tell me create role, and then I will create a database, and I'm calling that database SonarQube. And who will be the owner of that database? Sonar user will be the owner for that database. So I'll paste this here. Hold on, I didn't copy it properly. So I'll copy this, and then I will paste it here, and this will say create database. Now I will go to this section which will grant all privileges on database SonarQube to Sonar user. Again, the password that I'm also using for this is Sonar. So username is also Sonar, password is also Sonar. And quick verification, and we can run this verification. So first, let's do one thing. We will quit from the Postgres CLI. I'll enter this, and this is telling me yes, Sonar is there. And in the second step, we'll verify that the SonarQube DB indeed exists. And yes, it exists because I can see it here. So I will quit this one, and then this will not result in anything because right now we do not have anything in our database. So instead of strong password here, placeholder, let me write Sonar, and this will tell me that did not find any relations, which is all right at this stage. Now what we will do is we'll be tuning in certain SonarQube parameters. Now this all things are there in the documentation. I don't want to bore you with what I'm doing, but understand that you will be tweaking certain kernel level parameters for SonarQube to run properly. And then, as I always do, create a user for Sonar, so that anything that SonarQube is doing, that Sonar user is being used. So I will copy this and then I will paste it here. Again, in the comments, you can read thoroughly what we are doing, creating a dedicated user for Sonar with its home directory at opt SonarQube. Now, there are various download options for SonarQube. I am using a community build. You have different editions in production. Based on what your requirements are, you can choose the version that you need. So for now, I will cd into temp. I will download the SonarQube zip. I'll call it SonarQube zip, and I'll be downloading version 25.11.0. And I think this is the patch release or something. And then we will be installing unzip first, because we are downloading a zip package, and then we will move it to this directory, and then we'll be changing the ownership for this directory. So I will copy this, and then I will go to my terminal. I'll paste all these commands here, and then I will scroll further down, and then we are saying sudo -u with user Sonar. We want to edit the Sonar properties, and it is in the Sonar properties that we provide the username and password that we created a while back for our Postgre instance. Understand that here we'll be telling our SonarQube application to reach out to localhost port 5432, but if you host your database separately, you will add the identification, the DNS name, or the IP address, which is not recommended for your database instance. I will copy this thing from here, and then understand that we are editing it via the Sonar user. So I will press here, and then I will press enter, and here is the file. I'll press I to go in the insert mode, and if you see user credentials are to be provided here, I will uncomment this first, and then in the place of password I will write Sonar, and username I will also write Sonar. And here is the critical piece. Now I wanted this to be production like, which is why I am not using the default embedded H2 database that is, you see, default here, which could have been used for development work or for lab demonstration. But I wanted this to be as close to production as possible, which is why I am using PostgreSQL. You also have option to use Oracle or Microsoft SQL, and all these three options that you have, including PostgreSQL, are all relational databases. Again, you could use a self-managed database here, or you could be using a managed service by cloud provider. For example, you could have also used Amazon RDS for PostgreSQL here. Here first, since we are using PostgreSQL, I will uncomment this, and then I will have to provide the path here. So till localhost it is fine. Then I will add the port number, which is 5431 /. I'll go to my documentation, and then I just have SonarQube / SonarQube. Now I will hit escape shift ZZ to save this file. Now that this file is saved, I have to create a unit file. Now what is a unit file? Unit file defines a service. So we are creating a unit file named SonarQube.service. Now this is just a small configuration file that tells OS how to start, stop, and manage a service. So if you see here, we are telling it how to start, how to stop, and how to manage other things about the service. So if we are saying if it fails, you restart it. Then it also tells us what it depends on. So this is a Linux topic, so I will leave it here. Here we are creating a unit file. So I will come here, I will paste it here, then I will copy this content. I will go into insert mode, I'll paste it here, escape shift ZZ to save this, and then I will scroll down. Then daemon reload is fine. It will read all the files in the unit file location, which is this one, you know, this location. And there are other locations as well, but that is outside of this scope. Then we'll enable SonarQube. We'll start SonarQube and we'll finally check the status of SonarQube. Now, if you go to the GitHub documentation, I have written all the steps that are to be performed and what is the significance of those steps. Of course, I cannot cover everything in the video because if I do that, that will become a course in itself. So that is why I like to keep my documentation detailed so that most folks can get all of their answers within the GitHub repository itself. But if you need more information, then of course at the very last of my documentation you would find references which are typically official references which you can read to gain more understanding. But for now, our SonarQube service is running and we all are happy. So let's go to our browser and then I will sign in again. Why did it sign me out? Anyway, I will sign in again. I am in my instances. I'll go to SonarQube. I will copy the public IP address of SonarQube. I will write HTTP and then // I'll enter the IP. SonarQube listens on port 9000 by default. I'll press enter and it is not working. Congratulations. Is the IP correct? Yes, the IP is correct. Why it is not loading? Have I associated the right security group with it? Yes, I have. Port 9000 is allowed. Is it adding HTTPS by default there? What's the problem? Let me check the status of the SonarQube service. It's running, man. Oh, inactive. Let's try to restart that again. SonarQube is active. I want to check the status again. Code. This is fine. SonarQube current. This sonar.sh. This is fine. Let me go to my GitHub documentation. Let me see if this is loading anything here. There could be some error from my side only. Hold on. Let me try to run this. And I want to run this one. I ran this previously. Does it have it in its history? It may, but let's do it like this. And here I will write sonar. Oh, it doesn't see anything here. What I've done is I've also added troubleshooting steps. So let's go to the browser. And then here, if I scroll down, further down, further down, further down. Yeah. So let's check the logs. Because all these things are stopping in sequence. If I run free-h used free is there. Let me run that kernel parameter tweaks again. I think those did not run properly. Sudo systemctl restart SonarQube. If I stopped again, let me check other logs. I'll go here. So now let me check the web logs. Connection to localhost. Check the host name and accepting TCP connections. Hold on. I think there is some problem with the SonarQube configuration, sonar.properties. So let me quickly verify that this file. Just see if we have entered everything correctly. It's fine. Sonar, and this is PostgreSQL. And if I come here, we had to write 5432, not 5431. This was the problem, guys. I'll save this and more troubleshooting, right? Sudo system ctl restart sonar cube, and this time it should work. And let me write status. So that's why reading logs is important. So it gave us exactly what we needed. It said this, and then we reached this conclusion. If I check status, status, I have to spell it right. Status is now running. If I go to browser and then I hit refresh, perfect, it is working. Now the username and password, the default username and password for SonarQube is admin. So let us allow it some time. Oh yeah, admin. So we log in here, and then never. Old password is admin. New password, I'll set a secure password here. Press enter, and this I will do never later. So now our SonarQube instance is ready. Now we have all the three components that we need ready. So let's start with the demo. If I go to my diagram, I will take you to this screen. So first step is check out from private Git repository. Now for that, we first must have a repository. So I will go to this screen. I will go to my browser. I will go to this screen. Then let me go to the top here. And then from here, Cloud with Varjosh, and then I can close this one. This is not needed. I can close the YouTube link as well, and here I will go to repositories. Now let's click on new. This repository I will call cloud with varjosh hyphen private hyphen repo. This will be private here. I will scroll down and click on create repository, and now we have a repository created which is private. But I want you to clearly know that when you create a private repository, you need credentials to access it. So now we will be creating credentials that we will use to access this repository. So I'll go to settings, I'll scroll down, go to developer settings, and here I will go to personal access tokens, and then I will go to tokens classic. Here I will choose generate new token classic, and I will call this token Jenkins GitHub so that I know what this token is used for. I will choose repo here, and then I will scroll down and I will click on generate token. Again, do not show these tokens to your folks or colleagues. It is supposed to be private. I will delete these credentials before uploading this video. So I'll copy this, and then I will go to Visual Studio Code, and here I will just create a new file in the root itself, and not here. I would rather create this file in project files, new files, and I will call this creds, and in this creds file I will just paste it. You don't have to worry about rest of the details that are here. We'll dissect them, but for now just do this. Copy this here. Let me explain the code to you. So I will go to Java Maven. This is where I'm holding my code. So I have the src directory, And src has main and test. As we know, main will have my actual application code, which is in the file named app.java, and I have added some vulnerabilities so that I can demo this to you. At a very high level, this code will just be displaying cloud with Varjosh simple DevSecOps demo. And then there are test frameworks that I have defined. I have defined the JUnit test framework, and I have also defined a couple of test cases so that we can also see how code coverage behaves. And then I have my pom.xml. I have a simple pom.xml. I won't be explaining this pom.xml to you because we have already covered this deeply in our Maven lecture. So this is our code. Now I want this to be production like, which is why we will be committing the source code onto our GitHub repository side by side. But one point I want you to understand, that I will be using this token for my Jenkins to interact with this, and I am acting as a developer and I am also using this GitHub token. But in actual production, you will have two different tokens. One token will be used by Jenkins and another token would be used by developers. So with that understanding, let's start our work. So I will go to the terminal first because I want the code to be in my GitHub repository. So we will start by creating a new tab, and in this new tab, what I will do is I will cd into courses, and here Jenkins, and then this is common and java.maven. So java.maven is the directory that holds my src and pom.xml. So if I press ls, you see pom.xml and src. So if I run tree, you see I have app.java in my main directory, and I have app-test.java in my test directory, which is the standard structure that Maven would create for you. And I have the pom.xml in the root itself. So first things first, I will run git init. So git init will initialize this as a git repository, and then I will write git add dot, so that all the files that are currently untracked will be tracked by git. And then I will write git commit -m, and then I will call this commit initial commit with code and pom.xml. So always have meaningful messages. I will press enter, and then if I write git branch -v, then you would see my current branch is called master. But if I talk about GitHub, they would have named my branch main. I like to keep things consistent, which is why I will be renaming this from master to main. So I will write git branch -m, and I will write just main here. So if I run that command again, you would see my branch is now renamed to main. If I write git status here, you see nothing to commit. We have a working tree clean. So because we have already committed this initially. Now what I want is I want to add a private repository. So for that, what I will do is I will write git remote add private repo, and then the URL of that repo. So I will have to spell this correctly. I'm calling this private repo. You would have seen a lot of folks use origin here, and which is fine, but I like to keep the name meaningful, which is why I have used private repo. Now I will go to my browser. I will go here where I've created my private repo. I will copy the address of my private repo from here, and then I will just simply paste my repo URL here. I will press enter. Now, once I have done this, I have not provided any credentials yet. Okay. If I try to push it, it will ask me for the username. So for that, what I now want to do is I want to provide some credentials. So that is what we are going to do in this step. So what I will do is I will copy this, and then I will come to my Visual Studio Code. I will paste the command here, and then I will copy this token, and the placeholder, I will paste this token here, and then I will run this command in my terminal. Now, once I do this, now I can perform my pushes. I will write git push private repo main. I'll press enter, and then if I go to my browser now, and if I hit on code again, or you can hit refresh, you see we have src and pom.xml, and this is what you will see in your repository. Now as we progress, we will update this. Now that we have done this, let's create our first job. I'll go to, I'm already in my browser, and here I will go to dashboard, new item, and I want to call this job cloud with Varjosh DevSecOps demo, and this will be a pipeline job. I'll click OK. Now at this stage itself, I want you to know one thing very clearly, that I am using the main branch. But in production, main branches are often protected. See, I cannot cover everything that is used in production in a single project. So what I have done is, in this project, I have focused on security and both DevOps, and I've tried to maintain that balance. But I already have a lecture in my channel that tells you how to work with multi-branch pipeline jobs. So you can always watch that lecture if you want to see how the branching strategy in production works. And again, like I told you before as well, if you want full understanding, then you should also have watched the SDLC lifecycle, the branching strategies. And if you go to my Jenkins playlist, you will find first two lectures. They are not relevant to Jenkins only, they are relevant to CICD in general. So there we have discussed how branching strategy works in production, where you should keep your code, what are feature branches, what are release branches, and so on. So look at that. But for now, we are creating a pipeline job, and we will be working with the main branch itself. Now I will scroll down, and here I will choose pipeline script from SCM. Why pipeline script from SCM? Because what we will be doing in this demo is, we will be doing this production style. So our Jenkins file will exist in our repository itself. And then in SCM, I will choose git. And now we have all the things floated. I'll just move this to this space, and this I will move here. And now it is asking for repository URL. Repository URL is here. I will copy this. I will paste this here, and credentials, I will choose Jenkins. But Jenkins is not the credentials for this. Jenkins were the credentials for our Jenkins agent, not for GitHub. Now for GitHub, we have used the credentials in our CLI, but now Jenkins will also need access to our repository if it has to check out. So if you look at the first stage of our pipeline, it is to check out from private repository. If Jenkins must perform that checkout, Jenkins must be provided by the credentials. You have to engrave this in your mind, be it whatever CI/CD tooling you are using. Your CI/CD tooling is just acting as an orchestrator. You will still have to integrate different tools in your pipeline so that whatever you are trying to do, you can do those things. So I will go to my browser again, and this time I will click on add Jenkins. Kind will be just secret text. Now when I talk about GitHub, kind will be username with password. So when I talk about GitHub, GitHub expects the username along with the token, which is why we are using username with password. Now, why I am mentioning this distinction is because if I talk about SonarQube, there we will just use secret text, because SonarQube is not expecting the username, it is just expecting the token, and based on that token it will figure out with which user that token is associated. But with GitHub, you provide both username with password. So I'll click here. I will keep the scope global so that my pipeline can also access these credentials. Then I scroll down. Username would be cloud with Varjosh. That is my GitHub username. You will have to choose yours. And in the password section, I will have to paste the GitHub token. So I will copy this from here and I will paste this token here. ID would be GitHub Pat. That's a cool name. GitHub personal access token. I will click on add now. As soon as I choose those credentials, this red mark should go. If the red mark still says, that implies your token has anomalies. So fix it and provide the right token. And here is the branch specifier. My branch is main. That is why I will write main here. Again, if you want to know about multi-branch pipelines, then you should refer to the lecture that is already there in my Jenkins CICD course. I will click on save here and then let's click on build now. Firstly, I want you to notice that it is showing the current time. And why it is doing that? Because we changed the time for both the operating system and also for JVM. So if I click here, I can go to the console output and it will tell me why it failed. Now it is saying unable to find Jenkins file from Git. And this failure was obvious. Now, whenever we are running a pipeline job, we supplied that the Jenkins file you will find in the root, and that file was not there. So if I go to my repository, there is no Jenkins file here, which is why this job failed. So if I go to configure section and I scroll down, it was looking for a Jenkins file. Now, if you have not named it Jenkins file, you can provide that custom name and custom path here, and it will look for that file. But here we are keeping the things at default, and that is what it is recommended. You keep the name Jenkins file itself because your repository is private anyway. So you have Jenkins file, but we have not supplied the Jenkins file. So let's start the coolest part, that is writing Jenkins file. So I will go to my Visual Studio Code and always use an IDE which understands Groovy JSON to write these files so that you get color coding. And I will show you why this is so important in a little while. So I'll right click on Java Maven. I'll click on new file here and I will call this new file Jenkins file and I'll press enter. And let's start writing our Jenkins file. Now the first things first, I will write pipeline. Now pipeline is from where everything starts. So whenever you are dealing with Jenkins file, you start with pipeline and I start a curly brace. And as soon as I add one curly brace, my IDE is intelligent enough to know that he would also need a closing curly brace, which is why it added that. I will press enter. Now let's write the first thing that we want to do. We want to tell our pipeline that the agent that you should be using to run this pipeline or to run this job, what is the name of that agent? I will not be supplying the name of that agent. I will be supplying the label associated with this agent. Understand that for my entire pipeline, I'm just defining a single label, which implies the agent that has this label will be running everything in my pipeline, all the stages of my pipeline. You can have different agents with different labels, and then these labels or these agents can be called at different stages of your pipeline. For example, you may have an agent that only has kubectl. In that scenario, you would be using that agent to run kubectl specific commands. Maybe there is an agent that has Maven, SonarQube, and so on installed. So to run those kind of jobs, you assign that label, assign that agent. But in our example, we will be using a single agent which will be running our entire pipeline, which is why I'm defining this at the pipeline level itself. You also have the functionality to define the agent section or the label section within a stage as well. So with that understanding, I will write Docker, Maven, and Trivy. Understand that this name must match the name that you defined here. So if I open this one, I go to this agent, then you would see this one I called Docker Maven Trivy, which is why Docker Maven Trivy. Understanding this piece is critical, my dear friends. And then let's do one thing. I will press enter, and now I want you to see the important piece. I will write stages here. Stages is a plural, which is why I can have multiple stages. So I open a curly brace, press enter. Now inside pipeline, I have agent and stages. Agent and stages are at the same level. But now we want to add multiple stages. Hence, we must define different stages within the stages block. For example, I will start with my first stage, and the first stage, what I'm calling my first stage, is Trivy file system scan. Understand that within stages we have the stage block, but within the stage block we will have to do something, right? We'll have to perform certain steps within the stage block, and what those steps are, we define within the stage block. So in this stage, I am performing certain steps, and in this stage I will only be performing one step, which is sh. Sh is calling the shell. I will write Trivy FS exit code 1, severity high, critical, and a dot. What does this mean, Varun? Firstly, we are telling our pipeline job that the first thing that you need to do is you have to assign this job to an agent that has label Docker Maven Trivy. And once you have found that agent, you run this stage onto that agent, and that agent will be running this in its shell. Understand, we are defining in its shell, and what is the command that it should be running in its shell? It is Trivy file system exit code 1, severity high, critical. Now what we are saying with this line is, if there are any vulnerabilities that have high and critical associated with it, then I want you to fail this pipeline, because any exit code but 0 implies failure. So we are saying you fail the entire pipeline if there are any high or critical vulnerabilities. Now again, important thing is to understand how this syntax is working, which is why Visual Studio Code is so powerful, or any IDE that supports this color coding. See, steps has green curly brace, right? If I click on green curly brace, it tells me which one is the closing curly brace. So that is the color coding that you get. And you also see it is showing a box outside this, and this box signifies that this opening curly brace is associated with this closing curly brace. So if I click on this pink curly brace, it shows me, it highlights the opening curly brace. Similarly, if I check this closing curly brace, it tells me its association of the opening curly brace that it is associated with. So you get two things. First is color coding, and then you get this identification, because as you progress, you would see that there could be multiple white curly braces. Then this box helps you identify which one are the pair of opening and closing. So this is important to us. This one, you see pink is here as well and pink is here as well. So you know this opening curly brace is associated with this closing curly brace. So keep that thing in mind. Now let's get rid of the syntax. Can we run this command? Let's try. Actual production workflow. Here Jenkinsfile is in the root of our repository. So if I go to my terminal and I run ls, it will show me that right now you are not tracking this file. Why it is, oh, if I write git status, I'm sorry, if I write git status, it will tell you that Jenkins file is not being tracked right now. So let's do one thing, git add dot, and then let's add git commit -m added Trivy stage. Let's just write this for now. I'll press enter, and then I will write git push private repo main. I'll press enter. Oh, sorry, I have to spell it right. Private repo main. And this will push it. Now, if I go to my browser and I go to my private repository, I hit refresh, I see Jenkins file now exists and it was pushed, now. I will now go here. I'll go here and I will now click on build now. Now let's see what happens. I will go to stages, and this is a very good UI to see what is happening. So if I go to this, it tells me that my job has failed again. My pipeline has failed. If I click here, SCM checkout was automatically added because now it found the Jenkins file there. Previously, Jenkins file was not there, hence we didn't see this. Since the Jenkins file was there, it said your checkout works seamlessly because you provided the correct credentials. But the first stage in your pipeline, so to speak, which is Trivy FS scan, did not succeed. And why didn't it succeed? It says Trivy not found. And this brings me to that important point that I mentioned at the beginning. Your Jenkins is just an orchestrator. If your agent who is performing this stage of the build does not have Trivy installed, then your pipeline would fail. So now let's install Trivy in our Jenkins agent, because agent is the one that is doing the legwork, that is running our jobs. So I will go here, and then in this stage, Trivy FS scan, I will go here, and then I will scroll down, and this is how you install Trivy. Now you should be logged into your agent VM firstly. So let's install Trivy, and I am installing this in the default path itself. I'll show this to you. I'll just copy this right now, all the commands, and this is the version of Trivy that we are installing. If I go to my CLI, I will paste this in my Jenkins agent VM. First, I will exit this because I want to run sudo specific commands, and my Ubuntu user, if I write ID Ubuntu, is part of the sudo group, which is why it can run sudo specific commands. So I'll paste all those commands and I'll press enter. Now this will install Trivy. Now you would be thinking, Varun, but this will Jenkins user will have access to it? It will have access to it. And why it will have access to it? Because the location where Trivy is installed, all the users have access to that location. So if I run which Trivy, you would see that it is installed in USR bin. So if I run ls-l on this location, then you would see that everyone has permissions to execute this binary. You see owner has full, and then execute permissions are with groups and others as well. So our Jenkins user can also run this. Now that we have installed Trivy, let's go to our browser and run this again. So I will rerun this, and this time our Trivy file system scan should succeed. And let's see what it has for us. It says that, you see all the logs here for this stage, and this says it did not find any vulnerabilities. But you would be thinking, Varun, how is that possible? You deliberately added vulnerabilities in your code, right? If I go here, if I show src to you and then main and then app.java, you have problems in your code, but Trivy did not flag it. Why didn't it flag these? I want you to clearly know that Trivy we are using for SCA. We are in this stage and we are using Trivy for SCA. It will only look for vulnerabilities in your dependencies, not the actual code. For your actual code, you have SAST. Understanding this distinction is important. That is why Trivy did not detect anything. Now, I don't want to keep you hanging. What I want to do is I want to deliberately add a problem so that Trivy can detect it. So I will right click here. I will click on new file and I'll call this file secrets.txt. Okay. And then what I will do is I will add something that is in format of AWS secret access key. It is not a genuine key, but it works for our demo. And in pom.xml, I also want to add a dependency. I want you to clearly know that when I talk about Trivy, it can perform SCA plus more to detect CVE linked library vulnerabilities plus misconfigurations and known secret patterns that SAST cannot find. So for example, if I talk about this is a known pattern for secrets. But if I go to my pom.xml, if I go to my Jenkins code here, if I go here, then I have hard coded something, but this is not a known pattern, which is why Trivy won't detect it. And critical point, Trivy is mainly for the vulnerabilities that are there in your third-party libraries. And in pom.xml, where do we define third-party libraries on which our application depends? We define them in the dependencies section, which is what we are going to do. So I'll go to my browser, and I have noted all these points here. So I'll go here, I'll scroll down, and here is the vulnerability that I want to add. Hold on. Yeah, simulate a problem. So I will copy this, and then let's go to our pom.xml. And here, so this is dependencies is a plural. This is the first dependency. This is the opening tag. This is the closing tag because it has this /. I'll come here, I will paste it here, and then let me just align it properly so that it looks neat. And then this as well, I'll select this block, I'll press command and closing curly brace. This is fine. This is under it. Yeah, this indentation looks good to me. I'll save this, and now let's commit this. Understand, we have to commit. A lot of folks run it just like that. We have to commit the changes that we have done. So git add and then commit added Trivy stage with vulnerabilities. Enter and then push private repo main. And now I will come to my Jenkins screen again. This time I want this to check out the code again. So this rerun should not be used. I will come here and then I will click on build now. And then let me go to stages. Let me go here. And this time the Trivy file system scan failed. And let's see why it failed. It says your pom.xml has 3 vulnerabilities and your secrets.txt has 1 secret that is there. You fix that, dear DevOps engineer, and then I will let you pass, because I have been configured to fail the pipeline if there are any high or critical level vulnerabilities, and I see your code has 3, which is why I am failing. And then it also defines what has the problem and what you need to fix. And to fix that, we simply will delete our secrets.txt. I'll delete this. And what I can do is I can come to my code, I can come to my pom.xml, and this particular dependency I can just comment using command and / in Mac. I'll save this. I will again commit this, commit with vulnerabilities. I will just write fixed here, and then I will push this again. And if I run this again, I'll come here, I will run build now. If I go to stages now, you would see this has now succeeded. So if you come here, this says everything is fine. Now that we have done this, let's see what we want to do next. Next is your build and test. So this is the part where we will be building our application and we will be testing our application. So what I will do is I will just copy paste the commandlet because it is a lengthy command, and then I will be explaining you step by step what we are going to do. So let me come to Visual Studio Code and I will open my Jenkins file here. Stages, we have added the first stage. We identify where is this stage ending. I will click on this. It tells me that this is the closing curly brace for this. I'll come here, press enter so that I can add another stage here. And then I will just copy that stage for you so that I have to explain a few more things. So let's do one thing. I will write that stage first, stage, and I am calling this stage, let's say, build and sonar, because we are doing sonar scanning here. And then understand that we want to access our SonarQube installation from our Jenkins. So to do that, we must first provide credentials to do the same. So now let's add those credentials so that we can do the same. So let's go to our Chrome browser, and then here I will go to SonarQube, and here I will create a local project. And this local project I will call Cloud with Varjosh DevSecOps Demo. And the project key will also be the same. The branch will be main. I'll click on next, and follows the instance default, which is current default previous version. So what we are saying is new code is only the one that has changed from the previous version. Understand, as DevOps engineers, our primary motto is to reduce the time that the pipeline takes to run while performing everything that has to be performed. So if you have already scanned 80% of the code, I don't want you to rescan that 80% of the code. I only want you to scan the new code. That is what we are defining here. So I'll create project, and this has created a project for us. Now the project is created, but what we also want to do is we want to create a quality gate. Now by default, the project that we have created will get associated with the default quality gate that we have. But I also want to show you how to create a quality gate. So we will be creating a quality gate as well. So if I click on create, you would see that this UI appears, and it is asking us to name our quality gate. So I will name it Cloud with Varjosh DevSecOps Demo, and I will add a QP here so that I know this is a quality gate, QG rather, so that I know. I click on create, and you see it has copied all the rules, all the conditions that were there in the SonarWay built-in quality gate. Now, if you want deeper information, I would highly encourage you to watch the SonarQube lecture. But for now, we will add one more condition here, and that condition will be for the overall code, because we want to fail the pipeline if the overall code does not adhere to what we have defined. So let's say I want to fail the pipeline if the overall code coverage is less than 80%. I will add this condition. Now this quality gate is created, but right now it does not have any project associated with it. I told you that a project when created gets associated with the default quality gate profile, but right now we want to associate our project with the quality gate that we created. So without, I will click on this checkbox, and then if I come here again, I will see my project is associated with this quality gate. So this work is done. We have created a project, we have associated a quality gate with that project. Now we want to create a token. Now one way is you create the token for administrator user itself, but we don't want to do that. We will create a new user and I will call it Jenkins Sonar, and password, I will give it a secure password. We are not going to use this password anyway, but we have to keep a secure password. And name, let's call this Jenkins Sonar itself, and then email is abc@xyz.com, and then we can create this. Now we have to create a token for this user, and that is what is important. But before I do that, I will give this access to Sonar administrators. I'll press enter, and then here I will create a new token. I will call this Jenkins Sonar, and then expires in 30 days, let's say, and then I'll click on generate. You only see that once, like GitHub token. So I'll copy this. I'll go to Visual Studio Code, creds, and I will paste it here. Now I will click on close. We have the token. Now we have to add this credential into our pipeline. How do I do that? See, there is a way via which you can generate what you have to add in this step. So what I will now do is I will go to my Jenkins dashboard, and here let's go to Jenkins, and then I'll go to my job and I'll hit configure here. And then if I scroll down, I see pipeline syntax here. Okay, this can be used to generate certain scripts. I'll click on pipeline syntax and I will use a sample step called with credentials. I will choose with credentials, bind credentials to variables. So this creates a binding. Now why this is important? Because any credentials that you use like this will not be exposed in the console or in the, if you check the logs of your Jenkins. This is good because you want your credentials to be redacted, which is why we always use binding. So I'll click add here, and this time with GitHub we used username and password, but like I told you, SonarQube does not expect you to specify a username, which is why I will choose secret text here. Now what is the variable that you want to use, which you will use to call this secret? Understand, I have stored the tokens, but I need a way via which I can call this token, and that way is variable. So you define a variable, and I will define a very descriptive one, sonar token, so that I can use this variable. Now what are the credentials that you want to use for this? I will click on add here. I'll go to Jenkins, and this time I will choose secret text here. It is asking what is your secret text. I will go to my Visual Studio Code. I will go to creds. I will copy this one. I will paste it here, and the ID is, let's call this SonarQube token, and then we can click on add, and then I click on generate pipeline. So it will generate the exact syntax that is needed for us. So I will just copy this, or I can use this mark here as well. I'll go to Visual Studio Code. I'll go to my Jenkinsfile. I will come here within this stage, and within this stage I will have to, open a curly brace. I will open that curly brace, and then I will have to also add steps. What are the steps I want to use for this stage? And within the steps block, I will paste what I have copied. I'll hold on. I'll go here. Let me just copy this the old fashioned way. I'll come here, and this pink is for entire stages. This is for the pipeline, and this curly brace within steps that is green is for our step. So I will add this here. I'll go to view, and then I will also word wrap this. So with credentials, string credentials ID is SonarQube token, variable that we want to use is SonarQube token. And then here is where you can add the next commands that you want to run. And this is where I want to use copy paste. So I will copy the block that I want to use here, and then I will just paste it here. So here I am running a shell command. I am saying mvn clean verify, and if you have not been through Maven lesson, this will not make sense to you. But for now, what I can tell you is I'll go to this here. Maven clean will automatically run the pre-clean for you and the clean as well. So it runs the phase that you are running along with the previous all phases. In the next phase, I am saying mvn verify. So first it will clean and then it will run mvn verify. Mvn verify is this phase which will run all the phases that are before mvn verify. So it will also package, which is why you will get a jar file .jar, and it will also perform unit tests. Now how it can perform unit tests? So if I go to my Visual Studio Code, I have my pom.xml here. I have defined JUnit as a dependency, which is why Maven knows that JUnit tests are there. And secondly, there is also a Surefire plugin which is being used. And if you have watched the SonarQube lecture, all of this will make sense to you. So if I come here, we are essentially doing this. We are performing JUnit tests. And why we can perform this? Because we have defined a testing framework which is JUnit, and then I showed you the code as well where we have defined test cases. And in our Maven we have Surefire plugin which is performing these tests for us. And then further we have Jacoco. Jacoco is Java code coverage plugin. Jacoco records code coverage for SonarQube, and it delivers that to our SonarQube server. And that is how SonarQube knows that the code coverage is this. Understand that SonarQube can do SAST, but it cannot do code coverage. For code coverage reports, it depends on Jacoco. So let's move back and again watch the SonarQube lecture if this is not making sense. And here we have the Surefire plugin which will be running the tests, and Jacoco plugin is here which is delivering the reports to our SonarQube, and based on this SonarQube will be passing or failing our pipeline. Again, in the quality gate that we have defined, we have said that if the coverage is less than 80%, then you mark this as failed. But there are other parameters as well that you could have defined. So if I look the default profile, if I look at this quality gate, then you see there are multiple conditions that you can add based on which you can fail your pipeline. Now let's go to our Visual Studio Code and see rest of our Jenkins file. Then first I'm running clean, then verify, then I'm running sonar. So sonar implies I am invoking the sonar plugin, and in that plugin I'm invoking the sonar goal. So then we are specifying the project key that you want to use is this one, and this is the project key that we created in the UI while we were defining a local project. Now this is an important piece. Here I'm saying sonar host URL is this sonar IP, but we have not defined this variable anywhere. How do I define variables in a Jenkins file? For that, let's come at the very top of the pipeline, and here alongside agent I will create a line environment, and here I will use a opening curly brace, and then within this environment block I will add sonar underscore IP, and the IP that I want to use for SonarQube is I want to use the internal IP of my SonarQube virtual machine, which is this one. I'll copy this, I will paste this here. Always use private IP addresses. However, you could have also used public IP address. It would work just fine, but I wanted you to see how production implementations work. Now, Sonar IP value we have defined. Sonar token, it will take the credentials from here, that also we have defined. And quality gate, you have to wait for quality gate, that is true, that is self-explanatory. So we have done all these things. Let's run this pipeline, and I want you to think in your head, will this pipeline fail or will this pipeline pass? And here the step would be build and sonar. Okay, and then let's push this, and then let's come here. I will go here, and I will build it now. I'll close this, it has failed. So I go here, let me go to stages rather. So our this stage succeeded, and then build and sonar failed, and it says mvn clean this maven not found. Remember what I told you, your agent must have whatever it is trying to do. Here we asked our agent to run mvn specific commands, but we do not have Maven installed in our Jenkins agent. So either you install Maven in your agent or add Maven as a tool. Now we are going to add Maven as a tool in our Jenkins so that our agents can run Maven specific commands. So I'll go to my Jenkins, I'll go to settings, I will go to tools here, and then if I scroll down, and then here I will add Maven, and I'm calling this Maven 3. Now understand, you could be building different projects that may require different versions of Maven, which is why this exists. What I can do is I can call this Maven 3911 and know that this name is associated with this Maven version, and other installation that I add of Maven, that I can call Maven 3.9.1 if I have certain installations that depend on this Maven version. Understand, when you are doing this, Jenkins will be installing the required Maven on the fly, so your agent VM must have internet connectivity. If you do not have, then you can also add a zip. That functionality you have. So I'm calling this Maven 3, and the version I'm using is 3.9.11. I will save this, and then I have defined a tool, but I have not called that tool in my pipeline yet. So let me do that. I will come here, and here let's write it here below the agent. What I will do is I will add a section called tools, and this is where we define our tools. And the tools that I want to define right now is just Maven. But which Maven, my friend? I want to define Maven 3, and Maven 3 is the name that we gave to our installation. You see here, Maven 3 was the name, which is why I'm calling this Maven 3. Try to connect the dots. Now that we have done this, I will go to my terminal. I will do git add, then git commit, and then I will push this. So if I go back to my browser, here I can run this job again. So I'll go here, this one, and then I will click on build now, and I'll go to stages, and let's see what is happening. So Trivy stage succeeded, build and sonar. Let's see if it will succeed or it will fail. So it is running Maven specific commands. We know that because you see this has started progressing. And now let's see whether it will fail or it will succeed. And I want you to clearly know that in our pipeline, we will have three places that will decide whether the pipeline will fail or not. That is Trivy file system scan, quality gate scan, and Trivy image scan. So let's go to our browser again, and this has failed again. But this time the reason is different. Maven specific commands did run successfully, but if I scroll down, my logs will tell me a different story. So let's see what my logs are saying. It is saying script returned exit code 1. It is not giving me the complete logs. If I scroll above, okay, if I scroll further up, let me just zoom out a little so that I can see properly. Has it redacted the logs? Hold on. Maybe it has purged the logs. Let me come at the very bottom. Oh yeah, now I see the full logs. It says build failure, failed to execute goal this on this project. Status failed. What is this? And it is asking you to check here. It says the quality gate has failed. And why has quality gate failed? Let's see that. I'll go here. I'll go to projects. What? This is automatically created for us. And I want you to check a nuanced thing. They have named it this. We named it Cloud with Varjosh -DevSecOps -demo. But from where did this name come into picture? So if I go to my Visual Studio Code and I go to pom.xml, then the name that I have defined is this, which is why it is using that name. Now, if you have not watched Maven lecture, you are at loss here. So you see here, and if I go here, then you see why it has failed. It says the coverage is just 3.2%. The required coverage is this much. And then there are other problems with the code as well. If I go to issues, it will mark the other problems. Now, at this stage, this is the point where you reach out to your developers that we are getting these issues. Please fix this. Please make the coverage all right. Only then the pipeline will succeed. But since we are doing this in our lab environment, I think we can pass this using the means that you should never be using in production. So what I will do is I'll go to my quality gate. I will go here and then I will edit this rule and I will mark the coverage just 2%. So anything that is less than 2%, you then fail. But our code coverage is 3.2%. So it will succeed. But you should never do this in production. The minimum code coverage that I have seen in production is 65-70%, not below that. So I'll update this condition, and once this condition is updated, I will come back to my this job, and then what we can do is I can restart from a stage, and that stage is build.sonar. Let's see how it works now. I'll go to stages, and then let's see what happens in this stage now. This time the build is success because the quality gate allowed this to pass. Now we have a good understanding of how this works. So let's see what we want to do next. So I'll go to my diagrams, and in my diagram we have done both of these things. Now we have to perform ECR login and image build. So let's first perform ECR login and then see what we have to do. So I'll come to my Jenkins pipeline, but before we do anything pipeline, I think it makes sense to have a repository first. So let's go to AWS. I'll go to my browser, and then here I will look for ECR. Yeah, I want to use Amazon ECR here. I am in Mumbai region. I want to create a repository, and what I want to name this repository is Cloud with Varjosh -DevSecOps -demo. And I'll just zoom in a little so that you can see properly. Image tags setting, mutable or immutable. In production, you would always use immutable. Now, this defines whether redundant tags can be pushed or not. So always use immutable, so that if 2.6 version, let's say, exists, then no one else can repush 2.6, because that creates chaos. You don't want that. Now it is asking, are there any tag exclusions? And I will have tag exclusions. I will have a latest tag here. Now understand that when you are downloading, let's say, an image, and you do not supply a tag, you Docker typically adds latest as, the tag. But for that to work, an image with latest tag must exist in your repository. If that does not exist, then latest won't work. That is one thing. Second, what I'm saying is, if someone has pushed a latest image, and then if someone else pushes the latest image with the tag latest, then you should allow that, because we'll have to allow that, so that anyone who wants to use or work with the latest version of the application, they can just pull the latest tag. However, some level of controls must be there in your organization, so that whenever you are pushing a version that is the latest indeed, should have a latest tag as well. And that is what we will be doing. We will be pushing image with both the tags, a version tag, which we will see what version tag we'll be using, and then a latest tag. So I've added latest here. I'll click on add filter. Now if you are using KMS, you can use that. You can have your customer managed keys, your own keys, or AWS managed, but for this one I'll be using AES 256. Here I will just click on create. Now as soon as you click on create, it will tell you what all are the commands that you can use to push this. The URI is also available at your disposal. So if I click on this, I can view push commands from here, and this is what we will be using. So let's go to our Jenkins file, and let's add another stage. So this stage started with a cyan curly brace, and then I will add a new stage here. This stage is, let's call this ECR login. So we are going to log in into ECR, and here in this stage, these are the steps, and I'll add steps here, and then I'll add another curly brace, and then I will mention the step here. Now see what I can do. I can just quickly copy this, and I will paste this here. sh, I want to run this, and this is fine. But see, your pipeline will not look good if you have these lengthy URIs here. So, okay. So let's do one thing. Let's variabilize this part, and we already know how to do that. So I'll copy this, and then I will come at the top, and in the environment section, I will add another variable here. Let's call this ECR registry, and the URI is this. This is the registry. So I've added this here. Now what I want to do is, this is the variable name. So I will copy this, and then instead of this, I will be using that. See, if you look at this command, this is AWS specific command. It is using AWS. Hence, we must have a binary that understands AWS. What is AWS? It is essentially AWS CLI. To run this command, our Jenkins agent must have AWS CLI installed. That's first. Second, we are also using Docker login. So Docker must also be installed in our agent if we want this command to run successfully. So let's do that. So I will go to my browser, and here I will go to my GitHub notes, this one. I will come to the very top first, and then I will go to this stage. This stage is ECR login, install AWS CLI on Jenkins agent. I'll go here. This is not working. The click is not working. I'll have to fix that. But anyway, here are the steps to install AWS CLI, and you have to do this in your Jenkins agent. So I will copy all of these. And again, this binary we are installing, I think this will be installed in USR bin. for which all the users have access. So that will be available to our Jenkins user by default. So I'll enter these commands and this will install AWS CLI. And here if I run which AWS, it's installed here and all the users will have access to this. And we can also verify this using this command. So if I run this as Jenkins user, then I can check the AWS version. So AWS CLI is indeed installed. Now let's do Docker engine installation. So all these steps are taken from the official documentation. Here in the first step, we are removing if there are any installations of Docker already in your machine. This is not needed for our use case because we have set up a new VM. Then we are updating the index of all the packages. Here are the things that are required by Docker. We are adding all the keys, then we are adding the repository, and finally we are installing these things from that repository. So let's run all of these commands. I'll go to my terminal and then I will paste them here. Unable to locate is fine because the first command won't run successfully as we do not have Docker already installed. So that's expected. And once we are done with this, then what we will be doing is, this is an important piece. We will be adding our Jenkins user to the Docker group so that our Jenkins user can run Docker specific commands. And then again, we are also adding the Ubuntu user. If you wish to skip this, you can. Ideally, only Jenkins should be allowed, but I added this so that you can quickly test Docker right from your Ubuntu user itself. But in production, you will only use this, not this one. For this one, I can use both of these. So I'll come here, I will paste these, and I have done this. And then let's see the Docker version. So first we are checking the Docker version as Ubuntu user, and then this is that output, and then we are checking the Docker version as Jenkins user. So both of these work. This is good. Now I want you to understand one more thing. Will this pipeline run? Will this stage be successful? If not, can you tell me why? So let's do one thing. Let's first commit and then we'll see the logs and see how it works. Commit, and this one is your ECR login, and then I will write here push, and then let's go to our browser and I will come here, and I will build it now. Now you can go to stages and see how it is working. So all of these succeeded. We know they had to succeed. And here, let's see what the log says. AWS ECR get login this, Docker login this, unable to locate credentials. You can configure credentials by running AWS login. So you are trying to access Amazon ECR service from your Jenkins agent without supplying any AWS credentials. How will you be able to access Amazon ECR if you have not provided the credentials to access the same? Now, if your Jenkins agent was deployed outside of AWS, then you could be using AWS secret key, or there are other means as well. But we are in AWS itself. Both our controller and agent are in AWS. Our agent wants to access Amazon ECR service. How do I grant access to my agent? It is simple. I just attach appropriate IAM role, and my agent will be assuming that role while it tries to access Amazon ECR. So let's associate an instance profile with our Jenkins agent VM. But before doing that, we will have to create an IAM role. So I'll close this. Here I will choose role, IAM role. I'll come here, and here I will say, I'll zoom in a little, then I will say create role for AWS service, and yes, it will be EC2. EC2 is fine here. I will click next, and what is the policy that you want to associate with this role. Now I will use an existing policy. So here are the policies for public registries and for private as well. So if I go here, you see public and you see private. So we are using the private registry right now. That is what you would see in your applications. So we will come here and then I will choose EC2 container registry power user. I will select this policy and then I will click on next, and here I want to give the role name. So I will call this Jenkins agent role, giving this name, and then we will be using this name later as well. So name it in such a way that you remember it and always follow nomenclature that is understandable. So we are using this name and then I will click on create role. Now this will give our Jenkins agent access to Amazon ECR. So let's come back to the Jenkins job and then let's rerun this from a specific stage, and that stage would be ECR login, and let's see if this works this time or not. And this time it also fails. Let's see, why did it fail? Who will attach the role to the instance? So let's attach that role to the instance. We have just created the role. Let's attach that. And I didn't do it deliberately. Okay, I genuinely forgot. Security, modify IAM role. And here I will choose the IAM role that I just created. This is called the instance profile in this language. I'll select this one and update IAM role. And now if I run the pipeline, this should succeed in my opinion. Let's use rerun this time and let it run. This GUI is so intuitive to me. I like seeing this, everything green, green, green. It's so satisfying when you have a running pipeline. It has 10-15 stages and all of those are green. It's so satisfactory, I tell you. And then you see the login has succeeded. So we have performed the ECR login, but we have not built our image yet. So let's start building our container image. So I will go to my Visual Studio Code. Firstly, to build any container image, we must have a Docker file. And Docker file, you can find the Docker file in the project_files itself in the repository. So we will be upgrading this Java Maven with different things. We'll now add Docker file. So I want to copy this for now, and then I will paste it in Java Maven. I'm pasting it in the root itself. So if I see the Docker file, it's a simple Docker file. We are using Eclipse Temurin 21, that is Java 21. Working directory is /app, and then we are copying whatever is generated as app.jar inside /app directory. Now see, I told you whatever legwork is being done is done by the Jenkins agent itself. And if you remember, while configuring agent, we also defined what would be the Jenkins home in the agent. Where will the workspace be saved? What would be the scratch space that the agent would be using? And if you remember, we supplied /home /Jenkins there. So I am in the Jenkins agent right now. So if I sudo -u Jenkins, I log in as sudo -u Jenkins bash. I have to supply the command that I want to run. Anyway, so I'll go to cd home Jenkins, and that's the home of our Jenkins user. And if I press ls, you see workspace here, and you also see tools here. Now this tools will have Maven. So if I run tree here, do I have tree? Anyway, forget it. I'll cd into tools, and then if I do ls, you see Maven installation is here. I told you your agent will require internet access if you're using that tools section and you're not providing the installer. Anyway, so I'll come back, and if I go to cd workspace, you would see that whatever was there in our repository, you see here, and this is the name that we gave to our pipeline job. So if I go here and do ls, then you see Jenkinsfile is here, pom.xml is here, src is here, there is also target. And this was created because we also ran mvn verify, and that's why this was created. So if I cd into target, if I do ls, then you would see a file named like this was created for us, and that is exactly what we are doing with this command. So what we are saying is copy from target and you go to this file and copy that as app.jar. So you see this is the file that we are copying as. Try to think why we are doing something. And then we are exposing our application on port 8080. This is just for documentation. Your application should also be listening on port 8080. Our application is, which is why I have added that. Now another thing is entry point. This is the command that I want to run. When my application is running, I want to run this app.jar, this file, and that is what will show you Cloud with Varjosh, welcome to Cloud with Varjosh, and so on, whatever we are doing in the application. So we have the Docker file in the root now. If we commit, Jenkins would know there is a Docker file that I need to refer when I'm building something, but that build step we have not yet added. So let's start with that step. I will come here, steps, stage, cyan, closing bracket. I'll come here. I will add another stage, and this stage, let's call this one image build image. I have to spell this right so that it looks neat. And then in the stage here, I'll add this curly braces, and then I will have steps. I will again have curly braces. Now I will copy the command that I want to run. Just give me a moment so that I can copy it. I will paste it here. Perfect. Again, I'm invoking a shell. Then I'm writing export docker build kit 0. Now, why I am doing this? So this will essentially disable docker build kit. So builds, run in classic and predictable mode. Only that's the reason for this. And I will tell you why I'm doing this in a little while. Then our normal usual docker build command. I'm saying docker build -- platform Linux AMD 64. Now this is telling Docker that the image that I am building, the application that will result from this, supports AMD 64 architecture, and which is the reason the EKS nodes that we will provision as part of this lecture, the Amazon EKS cluster we provision, the worker nodes will also have AMD 64 architecture. Now you know why this matters. If you have developed your application for ARM and then you are trying to run that application onto a worker node that has AMD 64, then it won't work. And for further knowledge, AMD is the one that introduced 64-bit architecture. Then Intel didn't want to call it AMD 64, so Intel called it x86_64. But x86_64 from Intel or AMD 64, they imply the same thing. Why this matters is because the application that we are building, it supports AMD 64 architecture, and the base image that I am using also supports AMD 64 architecture. Hence, the image that I want to create is for the platforms that have AMD 64 architecture. That is what we are defining here. Now, why this becomes important is when you are dealing with enterprise grade applications, you want to be precise. You want to tell everything that is needed so that you do not get extra things free. So that's why I'm defining this. And when I was not defining this, my Amazon ECR had a few more blanks pushed to it, which is why I added this docker build kit is equal to 0. Nothing fancy. We have already used docker build so many times in this course, in Jenkins course or in my Kubernetes course. If you're new here, docker build is just building the container image. If you do not understand this, you are in the wrong lecture, because this is a CICD pipeline lecture which deploys onto Kubernetes. And to do that, creating container image is the first step. Anyway, I'm then defining tags. I'm pushing two tags. I'm saying the first tag is image repo colon build number, but Varun, you have not defined image repo yet. Let's define that now. I will go here and then I will say my image repo. This would be, I'm adding double quotes here, okay, because I will be using a variable within a variable. And then I will call this, and I'll tell you what I'm doing. I'm saying my image repo is ECR registry this forward slash cloud with varjosh hyphen DevSecOps hyphen demo. And this is exactly what you saw here on the console. So if I come here, exactly this, I'm defining this URI and then I will just define the tag. And what is the tag that you're defining, Varun? I'm saying $build number and then latest. Latest is, I'm sure you understand, but what about build underscore number? Now there are certain environment variables that are exposed by Jenkins and we are using one of those environment variables. Now if you want to access those environment variables, what you can always do is you can first copy this name. I'll copy it from here, I will paste it here, and then I will write env vars.html and I press enter. And these are all the environment variables that you can use that are available for your pipeline jobs. And here, what I am using is I am using a build number, and this is the build number that I'm talking about. So if I go to my pipeline, everything has a build number associated with all the runs, they have a build number. Now I am tagging my application with the build number so that when I see my image, I exactly know which build resulted in this build number. So what I will now do is, this is understood. Now you will also have your applications versioning as well, like which version of application you are using. I have not shown that here, but you must keep that in mind. So what you could be seeing is, here you could be using, like something like this app version and then a build number. So you are tagging your image with application version as well, and then the build number from which that image resulted. So that gives you full control when you see the image itself. Anyway, so we will just use this for now, and we have supplied that. Now that we have done both of these things, we can see whether this steps works for us or not. So I will go to my terminal again, and here I will go here. I will first add this and then I will commit this. I will say container image build, press enter, and then I will push this. Once this is pushed, I will come here, I will run build now, and this time I will go to stages, and you see build number 12 has started. And then permission denied while trying to connect to Docker API. Now understand, we installed Docker after connecting to the agent, correct? So we have to refresh that so that our controller adds agent with the refreshed permission. So what I will do now is I will go to my Jenkins screen. From here, I will go to agent. I will disconnect this. Yes. And then I will again launch agent. I'll see the logs. It says connection successful. Now I will run this job again. I'll come here and I will click on build now, and let's see the stages. And if I go here, this is running all the stages that we have defined up till now, and at the very last we see the build image stage. So let's see how it works now. And we are in this stage, and this time it has started building the things for us. No more that error. So just disconnect your agent and reconnect it if you also see those problems. Now it has completed. So it has completed building the image. So if I go to my terminal, I am already logged into my agent. And if let's say I run docker ps here, docker images here, I'm sorry, then you see the images. This is the base image that we are using. We don't care about this one right now. You see, there are two images that are created for us, one with the latest tag and one with tag 13. And why is this 13? This is 13 because this is build number 13, and we added the build number in the command that we were running in our Jenkins file. So we said that you must use the build number. Now that you have this understanding, let's move to the next step. What you would be thinking, Varun, why haven't you pushed yet? My dear friends, we'll have to perform an image scan to ensure that this image, which is our base image, when I talk about the Docker file used by our application, is vulnerability free. And that is what Trivy image vulnerability scan will do for you. It will scan your base image and its OS packages to see whether there are any vulnerabilities associated with it or not. So let's just quickly do that step. So I'll go to my Visual Studio Code, and same this time I will check this is the cyan curly brace, and then I'll come here. I will add another stage, and this stage I will call Trivy image scan. And then we have opening, closing curly braces. I'll press enter, and here we'll have steps. I'll again have an opening, closing curly brace, and inside steps I will have the command. And the command is extremely simple. I'll paste it here. Now I want you to see the difference. In the previous command, we said that Trivy file system scan, and I want you to run this on everything that is in the current directory. And I want you to clearly know what is the current directory. Current directory is the workspace where it has cloned everything. This is your current working directory. So it is saying scan everything here. But this time we are saying Trivy image fs has changed to Trivy image because we are performing an image scan this time. And if you find any high or critical vulnerabilities, then you fail the pipeline. So this is a quality gate that we are applying, that any high or critical vulnerabilities, you fail the pipeline. And vulnerabilities in the base image. And here we are supplying the image on which the scan must be performed. Simple. And then I will come to my terminal, and I will go here, and then I will quickly add commit with, I will write here Trivy image scan. And these messages are important, guys, when you are looking back at your history. And then I'll press enter. I will come to my browser. I will come here again, build now, and then I will go to stages, come here, and then let's see what our build image stage results in. Build image is already here from the last time. We want to see the next one, that is Trivy image scan. Trivy image scan. It's so good, right? It labels everything so properly. So Trivy image scan has appeared here. If I click here, then it is performing the scanning in our container image. And you see our command has expanded. Whatever we had variabilized, it now has 14 because this is build number 14. So whatever variable is being defined, that is resulting. It is not scanning anything stale. It is scanning what we asked it to scan. Now this scan is successful. Understand, the image that we are using is free of vulnerabilities, which is why it has not flagged anything. So With this said, we are good. And if I expand this further, yeah, output was, redacted by this terminal. Now you see the full output, and here is the detail for that. No vulnerabilities, and it is not just performing image scan, it is also performing something more, because it also scanned app.jar as well. In this step we wrote Trivy image. Now, to know more about Trivy, you will have to read about Trivy. It is not that this is a Trivy class. Understand that when you are integrating a new tool, you must first understand what that tool is using. We know as a principle that Trivy is used for SCA and is used for image scanning primarily. Other things, you read the documentation and explore further. And once you understand one tool, then other tools become so easy to understand. So for example, if you know Jenkins CICD, then be it GitHub Actions or GitLab, they seem like a cakewalk. Now that we have done this, let's see what we want to do next. Next is we want to push to AWS ECR, and they call it Amazon ECR, not AWS ECR. So we'll push to Amazon ECR. Let's see what are the steps for it. And again, these steps would be simple as in whatever you do when you are using manual methods. It is just Jenkins is automating things for us. So I will directly copy the entire block for this, because I don't want to waste time in doing simple things with you. Here, this and this, I'll come here, I will add this. Now I have added that stage as well. Now this is push to ECR. Steps is Docker push this, the image tag, and then the second image tag. We want to push both of them. So I'll go to my terminal, and here I will write git add this, git commit. I have to have a good commit message. Anyway, ignore this one. And here I will write git push private repo main. And then I will go to my browser, and here again I would run the same thing, build now. And then I will go to stages, let this complete. And once this is complete, we should see that our images, our tags will be here. Understand that we call this a repository, right? Like Ubuntu is a repository, and then that repository has multiple tags. And this repository, Cloud with Varjosh DevSecOps demo, has two images, as in two tags, one with 15 and another is latest. That is how it works. Now the push has already happened. Now is the last and the most interesting stage, that is deploying onto an Amazon EKS cluster. So if I go to Jenkins now, you would see this has pushed to ECR successfully, and then you can also see all the logs here. Now is the interesting stage, that is deploy to Amazon EKS. And this is also where we are failing. In case the deployment is not successful, we will be rolling back. So let's start working on this step. Now, before we start working on this, I quickly want to create a cluster, and I will just run the commands to create a cluster, and then I will walk you through what I am doing. Okay. I'll just cd, I'll come one step back, and from here I will cd into project files, and I'll do ls, and I will run EKSCTL create cluster, and the file that I want to use to create cluster is eks-config.yaml. Now what I am saying is create a cluster using this configuration file. Now to run this command, your thin client, as in your laptop or whatever you are using to run this lab, should have EKSCTL installed. You will find all these details in the GitHub repository, so do not worry about them. But you should have that EKSCTL installed, AWS CLI installed, and I will attach the steps on how to do all those things in the GitHub notes. You will press enter, and cannot find EC2 key pair. Hold on. Let me run AWS configure List profiles. Yeah, this is the profile that I am using. Okay, hold on. Let me make this profile default. Okay. Export AWS default. I think, I closed the session from where I was working in the practice sessions, which is why I have to, define the default profile again. And there are ways via which I can make this profile as, perpetual default, but I don't want to go there right now. So default profile is cwvj-sj, AWS default profile. Now we'll press enter. And now if I try to run that command, that should succeed because yeah, it has now succeeded. So that's a small roadblock. Now what we can do is, now let me explain you what we are going to do, because this creation takes some time. I'll go to my diagrams, and this is what we are going to deploy. We are going to create an EKS cluster, and in EKS cluster there is a control plane and then there is a data plane. The control plane part is managed by AWS. They will have redundant API servers and your HCD nodes, and they have three AZs where they will deploy your database, HCD, and then your API server along with other control plane components is also redundant. So here, for this part, you do not have to care because it is a managed service. Here is where I am using EKS managed worker nodes, wherein we will be creating two worker nodes exactly like this in two different availability zones. So if we are creating two worker nodes and that too in different availability zones, we want to ensure that the application that I am deploying is deployed in such a way that the pods associated with that application leverages both these availability zones. Otherwise, there is no point for me to have two AZs if AZ2 does not have any pods pertaining to my application. If my application warrants high availability of two AZs, then I must ensure I have means via which I can ensure that if I spin 10 pods, 5 will be in AZ1 and 5 will be in AZ2. That is your responsibility as a DevOps administrator. So for that to happen, we will have things in place. So this is the cluster that we are creating. Now let me walk you through the configuration file that I have used to create this cluster. Under project files, we used eksconfig.yaml. Extremely simple. We are creating a cluster. We are calling that cluster Cloud with Varjosh DevSecOps EKS. We are creating that in the Mumbai region. The version we are specifying is 1.32. AWS is offering 1.33 as well now, so you can use that. And then I am adding certain tags to the resources that will be created for this cluster. So these are those tags: owner tag, environment, project, purpose. And then I'm specifying I want to use two availability zones. IAM with OIDC is. And we discussed this in, if you want to, look at greater detail for this, there is an ingress demo in my channel and a stateful set demo in my channel, very detailed production like, and there I discuss all these things in greater detail. You can check that out. Then I'm creating a managed node group. What I'm saying is I'm calling this managed node group Cloud with Varjosh ng public, and public, I'm calling this public because the private networking is false here. So my nodes, worker nodes, will be accessible over the internet, which you may not need. I am doing this because the application that I will be deploying will be exposed using node port service. But Varun, who uses node port in production? And I agree with you 100%. But I wanted this demo to be within 3-4 hours. I did not want it to stretch so long, which is why I have not created any ingress or I have not deployed AWS's load balancer controller. If you want to see that scenario, there is a detailed 2.5 hours video in my channel that walk you step by step on how to do that and how to expose your applications using that. You are very welcome to integrate that application with this CI/CD pipeline. But for now, we will be exposing the application that we are deploying with Node port. Then I'm saying allow SSH. We won't need SSH, but I'm just saying allow SSH. And then public key name that I'm using is the same one that I use for instances. We won't be logging in into our instances, so this won't be used. Then I'm defining few add-on policies. Here I'm saying that true, 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 these things should be allowed. Labels, our nodes will have these Kubernetes labels, and then these will be the tags associated with our nodes. That is what I have defined. Now let's see where is our installation. So the installation is still going on till that point. Let's do a few more things that we want to do. So I'll come to Visual Studio Code, and then I'll come to Jenkinsfile, and then let's see the Kubernetes manifests that we will be dealing with. There is deploy-svc.yaml in project files that you can use. Deploy as in deployment plus the service manifest exists here. So if I go here, it is a generic deployment that you would have used thousands of times. I'm using 2 replicas, and then this is the important part. This is the part that will ensure if I have 10 replicas, 5 is in one AZ, 5 is in another AZ. Because here the topology key that I am defining is zone. So if I have, let's say, 2 zones, it will try to, deploy one pod in one zone and second pod in another zone. When unsatisfiable, I'm saying do not schedule. So this is a strict rule. You can be lenient with this. So if you hover over this when unsatisfiable, I think this will tell you. I mean, schedule anyway is another option I think that you can have here. Label selector, I'm saying this is applicable for all the pods that have app is equal to cloud with Varjosh DevSecOps demo, and that is the label that we are adding to the pods that will be part of this deployment. So very simple. Max skew is one that is default. You cannot have this 0. So max skew 1 says the imbalance of 1 is applicable, can be there, but not more than that. So skew is the imbalance that you can have. Here is the containers section, and you see these lines because we have not defined resources section as in limits and requests, which is why you are seeing this. Containers name is this image. Now this is the important piece. I am saying you have to use this image. Now I am saying latest here, but do not worry. We will have something in place which will have a specific tag here, and we'll see how that works. For now, just understand this is the entire URI of your repository. So if I go here to my browser, you see entire this. If I go to image repositories here, the entire this is here, and then we are saying the tag, we are supplying the tag. Port says container listens on port 8080, which is on what my application listens on. Then I am defining a node port service. It's a simple node port service that listens on port 31000. So we should be able to access this application on any of the node's public IP on port 31000 once the deployment is successful. So we have understood this. Now what I want to do is I want to add a stage in my Jenkins file, which will ensure that this file, firstly I'll move this to my this because it will be required to run kubectl commands, and it will be required by the next stage where we'll be editing this file to change this latest to something significant as in the build number. Let's do that. I'll come to my Jenkins file. I have this stage here in cyan, and then I will add another stage here, and this stage I will just call this stage proper naming, because in this stage we will be updating the deployment with a proper name. So I'll call this update deployment. Okay, and then here I will have opening curly brace, closing curly brace. Then here I will have steps, and within steps I will only have one step, and that step is this one. Now here I am using sed. So sed is a substitute utility which will let you substitute something with something. So here what I'm saying is substitute my image, with this one, and do that globally. So globally will not matter because we only have one place where we have to perform the changes. I just added G for completeness. So this, what will this do is it will go to image and it will find this, and then it will replace this with this variable. And this variable, both of these variables have already been defined in our Jenkins pipeline. So image repo is this, and then the tag is build number. So that is what this stage will do. Now let's execute this and I'll show you how this will work. Oh, this cluster creation is still ongoing. I wanted to push. So let me do one thing. I will have another terminal opened. I will quickly cd into courses, and then here I will go to Jenkins and then common, and from common I want to go to Java Maven, right? Java Maven is where I want to go. Here let's just quickly revise what we have done. It should have deployment and service manifest, which it has. It should have Jenkins updated file, which it has. So let's run this now. Let's commit this and then push it. So I'll go to my terminal. Here I will write git status. It should show that untracked files. Yeah, modified is Jenkins and this is untracked. So I will write git add dot and then git commit -m updated deployment image tag. Yeah, and then I'll press enter, and then I will write git push private repo main, and here I'll check the spelling and then I'll press enter. So now let's go to our Jenkins UI and I will quickly run this, and I'll go to stages, and by the time this is running, let's go to our terminal and see what is the status of our cluster. So the cluster is still being created. Let's again go back to our browser, and build 16 has failed. Has failed before even starting. Why is this? Console output update deployment. Oh, hold on. This should be in single quotes. That is what happens when you do things in a hurry. Now the color coding has returned, right? There are two parentheses after this. This should now work. Let me go here and then git add, git commit, git push. Now let's come back to Jenkins, and here I will build now, and then I will go to stages. Okay, this looks good to me now. So now what I want to show you is how it has modified. So let's go to our terminal, and here I want to go to agent. Yeah, and if I do ls, you see deploy -svc exists now. Previously it did not, because it is just this stage that we added this. Now I'll go to this one and it has updated the deployment. So this has ran successfully. But how do we verify that? So if I come here, if I cat into this deploy.yaml, you see here, this has changed. This was latest in our source code, but the checkout that Jenkins has performed, the file here in our temporary workspace has 17. I hope this is making sense and you are within yourself saying, this is how it all works. And now let's go to our terminal. We are already there. Let's see if cluster has been created or not. So cluster is still not created. Let's do one thing. I want to add that cluster step as well. So here is the cyan brace. I will add another stage. As long as you follow these curly braces and the color coding, you will never face problems with your, Jenkins files and their syntax. And anyway, if you face any problems, you can always give it to, AI tools to, format your files. It is all doable. And then I can have here deploy to Kubernetes, correct? So this is fine. Now I want you to know one more thing. We will be deploying these onto our Kubernetes cluster, right? So our Jenkins agent will be using kubectl client to run kubectl apply commands, correct? But our Jenkins agent does not have kubectl installed. So let's do that installation now. So I'll go to my browser and I will close this, and then here is, yes, stage 4 is done. We are on the last stage right now, and that stage is deploy to AWS. We have already discussed this, and then we have done this as well, and then it is deploy to Kubernetes. So first I want to check the installation steps. Yeah, install kubectl on Jenkins agent. So I'll copy this. I will go to my terminal. I will go to my agent, and then I will, no, Varun. I will exit. I have to run this as Ubuntu user because Jenkins is not part of the sudo group. And then I will run this. This will tell me whether, the second one will tell me whether Jenkins can access, and Jenkins can indeed access, Jenkins user can indeed access the kubectl client. Once we have done that, let's scroll up. I want the cluster to be created. Okay, the cluster has created. Congratulations. So let's go to the CLI. And here I want to show you a few things before we move forward. Elastic Kubernetes Service, clusters. And if I click here, if I go to tags, you see the tags that we supplied are automatically added here, which is what we wanted. So if I go here, if I now run kubectl get nodes, then I should see 2 nodes, because in my EKS config file, I asked it to create 2 nodes, minimum nodes 2, and desired capacity is also 2 of 20 GB each. So you see 2 nodes are there for you, and they are running version, the kubelet in my nodes is running version 1.32.9. So this is understandable. Now what I want to do is, I have created an EKS cluster. I have installed kubectl utility in my Jenkins agent, but I want to run this command. So let's go to our Visual Studio Code, and I want to explain this to you first here. So we have this, and then I will add steps here, and the steps that I want you to perform, dear, is these. So let me paste these steps. Okay, just give me a moment. If I come here, these are the steps I want to perform. So these are hefty steps. Firstly, I am running multiple commands in this shell, not a single command. Previously I was running single commands, hence I was providing, here I provided shell 2 times, but here I am running a chunk, which is why I have added all these under a single. So you have sh here, then I have 3 single quotes, I have added them. When you are running multiple commands and you want to invoke the shell only once, you can use this, and this one is the preferred way to do it. And then I'm saying AWS EKS update kube config. Understand, my Jenkins agent will be running the kubectl commands. Here I was running the kubectl commands as varun.joshi user. If I write AWS sts get caller identity, then it is varun.joshi that was running the commands, and varun.joshi has administrative level privileges, which is why he could see what all are the nodes that are running. Okay, using kubectl commands, Varun could see what the cluster has. If I run kubectl get pods, I can see this because Varun is by default, varun.joshi is by default have administrative access to the cluster. He's part of masters group, and we'll see what is that later. But for now, understand that user varun.joshi is able to do that, but our Jenkins agent has one identity, and that identity is the role that we associated with Jenkins, right? in Jenkins agent, we associated a role with our Jenkins agent. So if I go here, if I go to Jenkins agent, if I go to actions, security, modify IAM roles, then we added Jenkins agent role to our Jenkins agent, which is why Jenkins agent EC2 instance was able to access Amazon ECR. Now we want Jenkins agent's role to access our cluster. Now, if you are familiar with Kubernetes concepts, you know there is a kubeconfig file that is the source of authentication that your kubectl client uses to interact with your cluster. And now what we are doing is, in this step, what we are telling our Jenkins agent is, we are creating its kubeconfig file. So we are saying update the kubeconfig file, and you update that kubeconfig file for a cluster that is in AP South 1, that is in Mumbai region. The name of that cluster is Cloud with Varjosh DevSecOps EKS, because that is what we named our cluster. So keep that in mind. And then I am saying the kubeconfig file will be stored here. So for this to run this command, what I want is, I want AWS CLI to be installed, and then I want to update these details. In the second step, I'm saying kubectl create namespace this, and then I'm saying apply this manifest file. Now to do these things, my Jenkins agent role must have access to my Kubernetes cluster so that it can perform namespace creation, it can perform deployment creation and service creation. But we have not allowed our Jenkins role to do those things yet. Hence, we first must do that. So let's start with it. What I have done is, I have added AWS kubeconfig policy. Now to update this information, your Jenkins agent role must have access to your cluster. It has to perform describe cluster action. For that, we'll have to create a policy and attach this policy. So I'll copy this. I will go to my browser, and then in here I will go to IAM roles. Roles are here, Jenkins agent role. And here what I will do is, I will add permissions, and this time let's create an inline policy. Now inline policy can only be associated with one entity. That's what I'm doing here. I will choose EC2 here, and then I will say I want to paste a JSON, and then I will paste that JSON here. Understand that to run this command, your Jenkins agent must have access to this cluster. You are running EKS specific command. Your Jenkins agent does not have access to Amazon EKS yet. It just has access to Amazon ECR. You can only take actions on services for which you have been granted access. Now in this step, I'm granting that access to this Jenkins agent role so that it can run this command. Make a note that this still cannot be performed, and I'll show you why. And this time I'll write create policy. Policy name is required, temp EKS node access. Okay, so that I know that this is a temporary policy. I'll create this, and this is now added to this. Now let's do one thing. I will come here, and then I will try to run this. Okay, I'll come here first, and then let's do add, and then let's commit and write here deploy to EKS, and then let's write git push private repo main. And once we have done this, we can come to our browser and go to Jenkins screen, and here we can run build now. And once you do that, you will see it has started running. So let's go to stages and let's see how this pans out for us. Firstly, the deployment will fail. I'll I'm telling you right away. But let's see the logs to understand why it has failed. It has failed. And if I come here, it's saying added new context, and this is the important part. You must be logged into the server. You are unauthorized. It is using the correct kubeconfig file. It is not saying that it failed in this command. This command worked successfully, but when it tried to run this, it received an error that you are unauthorized. And if you have watched my Kubernetes authorization and authentication lectures, this will make so much sense to you. And we took the example of Jenkins itself in those lectures, especially in the service account lecture. And now let's do one thing. Let's come back here and fix the permission problems. Now, before I do that, I want you to know one thing. When I talk about AWS, it is the AWS auth config map that handles the authentication part. I'm choosing my words very carefully. AWS auth is the config map that handles the authentication part. So you must first authenticate to the Kubernetes cluster, and then if you have authorizations, then you can perform certain actions. Here we are just updating the kubeconfig file. Kubernetes cluster, we have not yet authenticated, we have not yet authorized to perform any actions in there. So we have to do two things. First, we have to fix the authentication, and then we have to work on the authorization part. First, we will work on the authentication, and AWS auth is the config map that takes care of the authentication. So if I write kubectl edit cm -n cube system, and then AWS auth is the name of that config map. You see here, we say map roles. Right now, this section that is added here, this is allowing your nodes to join this cluster. Because this exists, your nodes can join the cluster. But Varun, how come you are able to access your cluster if you run kubectl get pods? You have not added yourself anywhere, and you must be logged in into the server. Hold on, I think, just give me a moment. I used this one too. So if I run kubectl get pods, I am able to run this command, and here it was not running because here my identity is not that. If I run AWS sts get caller identity, this failed because my identity is not varun.joshi. It is varun.joshi, but it is not for the account that we are working in. So we are working in the account which has at the ending 648. Okay, but this CLI window which I am in the terminal, this is working on an AWS account that has 470 at the last. Although user is same, but it's a different account. But if I talk about this, if I run AWS sts get caller identity here, then this is using the 648 account, and I used this user to create my cluster, which is why this user has by default access to anything in this cluster. But this piece is not shown in the AWS auth config map, just for your information. It is invisible. It's like a golden key that the master has. Now we want to create keys for other users, and that is what we are going to do. We are going to add entry so that our Jenkins agent role can authenticate to this cluster, and let's do that. So I will run that command again, kubectl edit cm, and then I will go into insert mode, and then I will come here and I will go back here. I'll go back to Visual Studio Code now because I have to copy the part that I have to add here. Where I have added that, it is AWS auth edit. So I will copy this. I'll explain this to you in a while. It's very important, you know. And then I will go to my terminal, and here I will just paste this. I have to indent this properly because you all know how critical YAML is about indentations. So this has to be just underneath this. username can come here, group come here, and we are indented properly. So what I'm saying is the role ARN is Jenkins agent role, and you know how you fetch your ans. You go here, and ARN is this, and I have just added this ARN here, and I'm saying Jenkins agent role. I'm saying username is Jenkins agent role, and groups is system authenticated. If I would have added masters, then that would have given, all privileges, but I'm saying this is an authenticated user for me. Now once I have done this is the authentication piece. I have cleared the authentication piece. Now I have to walk in through the authorization piece, and for authorization I have an RBAC for you, and here is cluster role and cluster role bindings. Again, go to my CKA playlist and search for authorization. Learn about these, only then it will make sense to you. Here I am creating a cluster role. That cluster role is called Jenkins deployer role, and that Jenkins deployer role will have access to deployments plus replica set. It will be able to perform all these actions. Then it will have access to pods, all these actions, access to services, all these actions, access to namespaces, all these actions. And why I'm giving access to namespaces? Because we know that in our Jenkins file, we are also creating a namespace here. So, and then finally, we are creating a cluster role binding. Now, cluster role binding binds user service accounts or groups to cluster roles. Now, here, this would be namespace wide. And if you want more information about this, go and watch my authorization lecture. So, here we are saying kind is user, name of the user is Jenkins agent role, must match the username in AWS auth. So if I go to my CLI again and I run a describe on this config map, then you would see that the username is Jenkins agent role. The Jenkins agent role is here, and then the role reference, which is the role that you want to associate with this user, that role reference is Jenkins deployer role. And where is Jenkins deployer role? It is here. So this user will have all these accesses. So what I will do is I will apply this cluster role. So I'll go to the terminal, and then here I will press ls, and then I will run kubectl apply -f. I have to apply what? I have to apply cluster role bindings.yaml. And once I have done this, that cluster role and cluster role binding would have been created for me. Now I will come to my Jenkins pipeline again to see what do I have to do next. This will also work. This will also work. Now we have edited the AWS auth config map. So I think we have done whatever we wanted to do. Now let me quickly just commit this. Okay, I will run git add git commit -m deploy to EKS. No. Oh, here we have just done the changes at cluster level. We have not modified anything in our Jenkins file. So this should work. And just let me quickly see whether this file is already here. Docker file is already there. We don't need any of these. So let's apply this. I will go to our browser, and then here I will go here, and then let's run this thing. Build now, and then I will go to stages, and this should show me what is happening. Deploy to Kubernetes. Deployment successfully rolled out. So if I come here, I go to this terminal here. If I run kubectl get pods, I don't see anything. But if I write the namespace name, which was cloud with var Josh DevSecOps, then you would see I have 2 pods running, and I want to show that these pods are running on different nodes because we have applied that setting. topology spread constant. So if I write -o wide in here, then you would see that this is deployed onto this node and this is deployed onto this node. So if I go to my browser, I go to instances, I hit refresh, then you would see that two more instances should appear here for my cluster, and these are the two, the first one and the last one. We are good here, and both of these are deployed into different availability zones. So if I check here, 1A and 1B, rest of our infra resides in availability zone 1A. So we are good here. Now let's check the accessibility of our application. So I will copy this public IP address. I'll go here. I will write http:// I'll add that, and then it is 31,000. I'll press enter. It is not working. Can someone tell me why it is not working? It is not working because we have not allowed port 31,000 in our security group. So let's see what is the security group that is associated with these instances. So if I go to security, and then I see these are the two security groups. Now I can edit either of these, but I will prefer this one. I'll go here, edit inbound rules. I will add an inbound rule. I will keep it custom, and here I will add 31,000, and then here from anywhere I can save this rule, and this should now work. Yeah, cloud with Varjosh, simple DevSecOps demo. So we have deployed an end-to-end pipeline. Now, just to improve certain things, what we can do is we can have certain post actions in our pipeline. So that is exactly what we will do now. So I will come here. I also want to show you the logs for this one. So I'll go here, and then you see rolled out was successful, and this worked because in our pipeline here we said if we gave 60 seconds, in case this was unsuccessful, then we would roll it back. Now we have done this. This is this stage. What I want to do is outside of stage, I want to add certain post actions. Again, you can have post actions within stages, but you can have them for the entire pipeline. Now this action, I want to have it for the entire pipeline. So stages were starting here, but pipeline was starting here. So I want to add this within the pipeline block. So this closing curly brace was for this stage. This closing curly brace is for the stages section. You see this highlighted here. And then after this, I want to add our post actions, and this is the post action. So if it is success, pipeline is successful, we will print this, and failure, we will print this. Always we will print this, no matter what. We'll say finished. We'll save this. We will go to iterm. We will go to this screen. We will add this, then we will commit this, and we'll add a meaningful message, post actions, and then we will just simply push it using this command. Now if I run this pipeline, we will also see post actions, and that is what we want to see now. So you can click on stages to see. Oh, I have a mistake. Let me go to the console output workflow. Hold on, I have a curly brace error. Oh, this there is no curly brace that is closing this pipeline, right? This has turned red, which is why. So, oh, Varun. Then I'll add this here. Okay, try speaking, getting recorded at the same time. It's not easy as it seems. And then I have this. This should work now. So I'll go to my terminal, and then I will add, and then I will commit, and then I will push, and then I will go back crying, and then I will click build now, and this should now work. I'm hopeful. Okay, it has started at least, so something would work, right? I'll go here, and this should work. And by the time this completes, I want to walk you through some more things that you would be dealing in production. Stage 9, post actions. Yeah. Post actions. Now see, why would you use post actions? Now I have given a very simple example. You could be using post actions to send emails. You can, regardless of what happened inside the stage, you can send deployment notifications, push artifacts, tag builds as stable. There are so many things. Create Jira ticket, log failure metrics in case of failures, and so on. So you could be using all these options, and maybe as I create another project or another demo, I will be using some of these. But I want you to keep these things in mind. If it's a success, you would want to send an email that the deployment succeeded. You can access the application here and so on. Then what we have been doing up till now is we have been clicking on build now for our pipeline to run. But you can always create webhook, and when you create webhook, whenever you push onto your repository, a pipeline will trigger automatically. I have jotted down all the steps to do that. It's extremely simple. I would highly encourage you to do that. And then lastly, I want to talk about a few things. This pipeline is production ready, but there are major chances of improvement. You can improve this. First is deploying Kubernetes ingress. So I have detailed lecture for that. You can refer that. Multi-branch pipelines. You will never ever be pushing directly onto main. All these main branch, development branch, production branch, whatever Git strategy you are using, it could be trunk based or it could be git flow based, but your main branches, your development branches, your staging branches, all these will be protected. You will only be allowed to push onto your feature branches, and then a PR will be raised. I've covered this in depth in my multi-branch pipeline lecture, so do watch this and try to implement the pipeline that we just implemented using this. Before I move to the next one, let's see what is Jenkins doing. So the deployment is successful, and as suggested, post actions are here. It says build 21 finished, build 21 succeeded. That is what we wanted to see. So let's continue what we were discussing. So here I have not introduced Argo CD because I don't want to cover any topic that I have not covered in this channel. So I will soon be covering Argo CD, and once I do that, I will be creating projects that would be leveraging Argo CD. We have used private IP addresses somewhere, but we should be using DNS names. Use image digests. Now we have provided tags, but in production implementations, what you would see is you use image digests instead of tags. And you see here, our latest tag is being replaced as we move up with the pipeline. So we started creating our images from build number 15, and we completed this demo in build number 21. So if you go here, this is our build 21, which is why you see 21 is the latest one. And here is the digest for this, which is what I was saying. You would be typically using digests in production implementations, not these tags, because these are indeed immutable. You use digests in production. Then other improvements that can be done: signed images plus policy enforcement. There are things like Kyverno that can be integrated, centralized secrets manager. So right now we have used credential bindings. Bindings is one step in securing your credentials, but you can also use a product that is meant for secrets like HashiCorp Vault or AWS's Secrets Manager. Then observability integration. So we have not integrated any CloudWatch, Datadog, or anything. We are not doing any monitoring of sort. So you could be improving this pipeline by this. Policy as a code. We have not used any security related policies or any Helm or Terraform for deployment. You could be using those things. Argo rollouts I've already covered, automated cleanup and cost optimization. So we have not done these things as well. You could be doing these, and there could be plethora of other improvements that you already are thinking. So we can integrate all of these things, but I assure you, a demo with this much depth will clear a lot of your doubts. Now I will go to my diagrams and then I will wrap up this lecture. So we have created this robust pipeline, and with this on screen, I wanted to end this lecture. So that wraps up DevSecOps mega project, where we built a complete production style CI/CD pipeline using Jenkins, Trivy, SonarQube, Amazon ECR, and multi-AZ Amazon EKS cluster. You saw how real teams use security gates, SAST, image scanning, immutable artifacts, IAM with RBAC, rollouts checks, and automatic rollbacks to run safe deployments at scale. If this session helped you, drop a quick thanks or hi in the comments and subscribe for more advanced EKS, GitOps, DevSecOps content that is coming soon. I will see you in the next session. Thank you very much.